Yes, Sorin, you can lead us now out of prayer.
Let's humble ourselves and we pray. Almighty God, we thank you for the gift of today. As we are going to attend this lesson, may you lead us through until the very last end. In Jesus' name I pray.
Amen.
Amen.
Okay, thank you so much for the word of prayer. I have disabled all your microphones and some features such that we do not have any noise in the background, but also to be able to run smoothly throughout this session. So I want to welcome you for this session. Thank you so much for coming and for sparing time to be here. The reason as to why we are here, we have come to learn physics, but also to share what you are supposed to do when it comes to the physics practical. Our major focus today is going to be on the physics practical. Anything that we are going to be sharing is on physics practical. So we are going to share everything concerning the physics practical and how you are supposed to maximize in this particular paper. So my name is Stephen Kaziba, and I'm going to be the one to take you through this session. Please tighten your belts. It is a long session. It will take us about 3 hours. And at one point, I'll ask you, we shall have some activities that we shall get involved in. I want also to welcome the teachers that have joined on this call. Thank you so much for coming, and everyone that has joined to learn more about the physics practicals. So allow me now to dive into the presentation. So what is the format of the physics paper? We have 2 papers in physics, and the first paper is called 5351. And this paper consists of 2 sections. So section A and then section B. In total, we have 7 items that we are supposed to look through and then choose the number we want. When you look at section A has 3 compulsory items and section B has 2 parts. So it has the first part and it has the second part. But in each of those parts of section B, you choose 1 item. But for section A, you do all the items that are there. Then in total, since we have the 3 items and the 2 items, every child is expected to answer 5 items in total. 3 compulsory items from section A, and then 2 numbers from the section B. But in section B, it is according to your strength. It is according to the way you have prepared yourself for you to answer. Then that paper is for 2 hours and 30 minutes, meaning that roughly every number should take you 30 minutes. Every number is for 30 minutes. But if you use 30 minutes for every number, it means that you may not be in position to complete the paper. So you need to budget your time well, such that you are in position to complete the paper. Then when it comes to paper 2, the code is 5352, or it can be 3, depending on the number of students you have in a school, or depending on how many you are in a school. When the school has a very large population, we usually have another paper we call paper 3. So the paper has 2 examination items. And those items, every candidate must answer 1 item. So you choose 1 item from the 2 items that they have been given. Then the paper is for 2 hours. So the 2 hours, it involves you applying all the inquiry process skills such that you can be able to finish the paper. So for this one, it is for 2 hours. Then the other paper is for 3 hours. Now, what is the test frame? Now, the test frame 1, the framework 1, we have what we call a construct. When we talk about a construct means a specific knowledge. It means that knowledge area. It means that skill. It means the behavior. What is expected from a child when you do a given body of knowledge, when you do a given discipline? That's what you call a construct. That you offering physics what knowledge are you supposed to go out with? Which knowledge do you know? That's what we now would call a construct. The behaviors that you demonstrate, the behaviors, the skills that you can be in position to show, we call it the construct. So physics has what we call the construct. And under the constructs, we divide them into what we call the elements of construct. Now, an element of construct is developed by arranging different areas that are related and they form into one section. So elements of constructs are like the different section whereby we get all the topics that are related and then we combine them. We put them under the same knowledge. An example, take an example. When you are talking about fruits, you can decide to say that fruits, we have mangoes, we have oranges, we have pineapples, and the rest. So those ones, you put them under fruits. Then in case you are talking about maybe foods, then you bring things that are related together. So those are what we call elements of construct. So all topics that are related are always put into one element of construct. And we are going to look at those constructs in details such that you can get to know which topics are you supposed to, which topics do you do in that particular area, or which topics are contained within that particular area. When you talk about optics, which topics are under optics? When you talk about the galaxies, stars, which topics are under that space physics? So those ones, we have them in physics, and those are the ones that form the basis for the assessment. So those constructs form the basis for the assessment. Okay, now what are the elements of constructs? Now, the compulsory section has 3 elements of constructs. Those elements, let me break it into, let me call them like sections. The first section contains what we call stars, galaxies, and digital electronics. The second one has light and waves. And then the third one has atomic and nuclear physics, meaning that all the topics that you have been covering, that where you have been meeting stars, galaxies, and digital electronics, that one is going to be one item. It's going to be one question. Then you have been meeting light and waves. So take an example. In light, you have looked at reflection of curved mirrors. You have looked at lenses and optical instruments. So that one, it will be one question combined with waves. Then under atomic and nuclear physics, here you're going to look at modern physics, those who have not yet looked at it. And now that one is going to be another number of its own. Then when it comes to section B, where you have to choose. Now here you have 2 items, or you have 2 elements of construct. And those 2 elements of construct are the ones I have put in yellow. We call it mechanics and heat, electricity and magnetism. So you choose one number from mechanics and heat, or one number from electricity and magnetism. Then the last element of construct is in the practical, what we call scientific investigation. And now that is where we are going to focus our session today. However, before we dive deep into the section, I want to let you know such that you can be able to know when I'm revising for physics, which areas under stars and galaxies and electronics must I first concentrate on, or must I know? Now, under stars, galaxies, and digital electronics, these are the topics, and this is where you covered them. So here you choose one item. So when you are revising, when you are making your revision plan, you need to know that what am I going to be revising? So when you start revising stars, galaxies, and digital electronics, it means that you must know the solar system, you must know about satellites, you must know about digital electronics. So that is one compulsory question that is being set. So that means that in that section being compulsory, you must be very competent in it. You must know it. Then the second one is what we call light and waves. So under light and waves, all these are questions, or these are the subtopics under it. Some of these subtopics, you cover them in senior 1, others in senior 2, and others in senior 3, like I have indicated for you. So when you are revising, that means that you must know this section of light and waves such that you are on a safer side. So all those topics, you must know them under light and waves. So this is still section A. Then still when we come to section A, now I have summarized for you this table. So when you look at this table, these are the topics you should expect when it comes to section A. The elements of constructs are three: light and waves, atomic and nuclear physics, stars and galaxies, and then digital electronics. So any student that wants to pass physics, you cannot go into a paper minus you knowing all these topics. Minus you knowing light and waves, atomic and nuclear physics, and then stars and galaxies. So this should be your area of focus, that now I have finished, I have mastered these ones, I can move on. So you must know this topic such that you can be able to maximize in the compulsory section, because for it, you not have any option, but you must do everything as it has been given to you. Okay, then section B, these are the topics. Under mechanics and heat, you must know these topics. Some of these topics are for senior 1, others are for senior 2, others are for senior 3. But when you look at mechanics, all these ones are covered from senior 1 to senior 3, and there is nothing you cover in senior 4. Meaning that now here you have retained a lot of knowledge concerning these topics. So please, when you are revising, remember there are 2 questions and then you choose 1 question from mechanics and heat, meaning that you must be strategic. You must be strategic and do not spot that, I'm going to revise only heat, I'm going to revise only motion. No, the question can be combined. Remember here we combined a scenario whereby we can put different topics into one. So that means that you must have knowledge on each and every subtopic. Then the last part of the part 2 of section B is what you call magnetism and electricity. Part of this one, I am sure you have even covered them here at Hope. You have covered about electrical energy, distribution and consumption. I think that was last week, and other topics. So now that is your part 2 about magnetism and electricity. So those are the different sections you must know when it comes to section B as you prepare for your theory paper. In case you have any question, you can keep it and then you can ask at a later time. But I will give you a chance for you to be able to ask. Okay, now I'm going to dive into why we are here. So today our focus is on practical, which is paper 3, and we are going to look at how this paper is handled and what we should expect. Like I've told you, we have what we call an element of construct, and that is what we call the scientific investigation. So in science, the element of construct, be it chemistry, be it biology, we shall call them the scientific investigation. This is like an approach in science that helps us to find out more about something that keeps on that in case you want to dig deep and find out more about something, we say you must investigate such that you can come up with the result, and then you can base on that to make a conclusion, and then you can give the advice and the recommendation as you have seen. Now, under practicals, we have sections, and the first section we have is mechanics. The second section we have is optics, and then the last section we have is electricity. So the questions or the items being said can come from any of these 3 sections. And when it comes to the practicals, you must take on 1 item. However, how are you supposed to go about this? So now these are the 3 sections where the questions are going to be set. 1, what are the item choices? 1, an item. In practicals, we shall have 2 items being set. And in those 2 items, those items can either come either from mechanics or optics. That can be 1 option for the paper. So the examiner or the person setting can either choose to set 2 questions, 1 from mechanics or optics. But this examiner can also choose to set either from mechanics or electricity. But also he has another option of either setting for electricity or optics. And you as a student, you must answer or attempt 1 question from the 2 items being set. But here, the examiner has the liberty to set from any two sections of his choice, meaning that you should not go on and spot and say, me, I'm doing mechanics only. Me, I'm doing optics only. Me, I'm doing electricity only. No, you must be conversant with everything, because we have said at the beginning, the reason is that you must be, for you to be considered, for you to be called a competent physics child, you must be able to know all the three sections. So make sure that as you put in the efforts in these last few days that are remaining for you to sit for your finals, get well conversant with those sections, because you are going to be meeting them in real life, and that knowledge that you have acquired through those practicals that the teachers are going to be giving you would be the one to save you. Okay, now what are the focal areas? Our presentation today, we are going to, one, to look at item choice. How do you select a good question for you to attempt? Two, we are going to look at the steps in scientific investigation. So those are the two areas we are going to look at. Now, one, item choice. What do you look at when you are choosing an item to answer? After receiving your paper, or after getting that paper, what are you going to consider? Or what are you going to look at and say, let me do this number, let me do this number, and why don't I do the other one? So one, you must first use the 5 minutes of your time. Remember, we said that this paper is for 2 hours. Use the first 5 minutes of your time to read thoroughly through both the items that have been given. They have given you 2 items, read through them, go through them, interpret them the first 5 minutes. Look at the one that is related. Look at the one you feel you might have some knowledge, you might have some clue. Then after that, relate those items to real life contexts. All the items being said are going to be reflecting real life. They are going to be things like you see around yourself. So relate which one. Take an example. They can ask you, it can be about water bottles, measuring the mass and the rest of that. But you have been seeing them around. So that one can easily relate. That you have been seeing people picking water bottles and the rest. You have been moving around. And whenever you move around, you find people who have aged, people who are aged. You find them getting newspapers and reading them from a distance. You have seen them. You have seen children at school who want always to sit in front because they cannot see clearly. All those are physics concepts that you must know. So relate it to real life context. Ask yourself, where have I seen this one manifest itself? Where have I seen this situation? Because that one will help you to give a good recommendation and as well as a good conclusion. Two, look at that problem, look at the scenario and identify the problem in it. What is the problem that the person who has set is looking out for to solve? Because many times we are looking for problems to solve. What problem does he want to solve? Because once you identify the problem, then it means that you can be in position to find or to provide a solution. You cannot provide a solution when you don't know the problem. So you cannot be able to do well in the practical if you have not identified the problem. So read through and then find out what is the problem that they are addressing in the practical. Then check the apparatus that the teachers have provided on you on the table. Look through all the items and then start relating the question to the items being provided. If there are any other items that you may need and are not provided, then you can go on and ask for those items. Then make sure you make a choice of the item that you feel you are much comfortable with. Read through. There are 2 items, but make sure you choose the one you feel you are going to be more comfortable with. The one you feel is a bit easier, light for you. Don't choose something that is very complicated, thinking that they will give you free marks because you tried. No, there are no free marks. So you must work for the marks that you want. So meaning that do not choose something you feel you see that is a bit complicated. It requires a lot of time to reason, and within 2 hours, you may find yourself not completing. So make sure you make a choice of something you feel you have a clue about, and then go on and summarize the item chosen. Now, summarizing the item, try to figure out how will my table look like? Which variables am I going to use in the process? After you seeing that, then that one will give you a good clue on which item to go on and choose. Okay, now other key subtopics we are going to look at under mechanics. As you are revising and preparing for these practicals, you have been doing very many experiments from different subtopics, from different topics and the rest of that. But each of those sub-practicals you keep on performing has a real life related problem it is trying to solve. Much as you might not be doing it the exact way, or much as the teacher might not have related it to real life, but it has a real life application where you can use that knowledge to solve a challenge. Meaning that now, as a person, you must be in position to know which practicals must I know, which practicals must I be in position to state the procedures. Now, as you are revising for mechanics under the section of mechanics, these are some of the subtopics under mechanics that have very many practicals that can be set on them. One of them is on measurements. When you look at measurements, we have very many practicals that can be set around that area. Take an example, under measurements, you'll find that there are practicals concerning density, concerning relative density that can be set. And you know that relative density is applicable in real life. So as you are revising, you must be able to remember relative density. How do you calculate? What is the procedure? How is it related to real life? Like an example of relative density. Whenever you want to find the purity of a given sample, you want to find out whether something is pure, then it means you need a relative density. So in case you have any sample you want to identify, you use the relative density. When you go to minerals, geology, those people who deal in minerals, we call them the geologists. They use it. So you need to know how to use them. Still under the measurements, when you look at volume, when you look at more volume, also there are practicals that can be set around that given area. Now go to what you call turning effects or forces. You have been looking at things like moments. Moments are very applicable. You want to find out the mass of one object in comparison with another known mass. We shall use the moments. Look at Hooke's law. When you are looking at the construction, when they are building in real life, when they want to know the load a given material can support, we shall use those things. So don't not undermine them by you not revising them, meaning you must know them. So make sure that experiments rotating around that area, you know them and you make more research about them. I have not completed the full list of some of the subtopics, but I've just highlighted a few of them that at least you must know. When it goes to light, one of them can be nature of light, reflection at plane surfaces. You can look at curved surfaces. You can look at refraction and then lenses and optical instruments. Here, all light experiments will rotate around this. They are going to be rotating within that area. So meaning that if you don't know how to deal with one of them, you may find challenge. So meaning that now you need to sit down, look at those experiments you have done within that given topic of, let me say you have done lenses, you have done reflection. Look at the topics. Those topics have real life application. Take an example, you have looked at glass blocks. You may think that a glass block doesn't have a real life, but in order for during the manufacturing, for you to determine which glass to put into a house, to determine which glass to put onto a laptop, to determine which glass to put into a car, always look at the refractive index of that material as one of the properties. So they can ask you a practical rotating around that area. You have looked at lenses. For you, those you have seen some of your friends having glasses. That is an application of lenses. You have seen mirrors. You have mirror. You have gone to salons. You have seen different mirrors being used. Those are application during the shaving and the rest of that. So meaning that there are practicals around that area that you must know how to carry them out. when it comes now to electricity, here you are going to look at mainly two of them. When we come to introduction and when we come to Ohm's law, many of the electricity experiments will be rotating around that area. But also they can ask you the commercial one, whereby it involves the calculation. So that one of senior 4, when it comes to commercial electricity, they can as well ask you. I didn't include it here, but it can also be one of the points of focus that can be asked. Okay, so those are some of the things, those are some of the topics, those are some of the experiments within those given area that you need to focus on. Sharpen your eye and ask yourself, do I know all these experiments within this given topic? Can I relate them to real life? Can I relate them to a context within what I can see? Take an example in electricity. For any connection to be carried out, you need to know the resistance, you need to know the resistivity, you need to know the length of the wire and the rest of that. Those things are rotating about Ohm's law. Not that they just bring any wire of their choice and they connect. No, they must first know what is the resistivity, what is the resistance per meter or per centimeter for them to connect. So you have seen at times people who connect anywhere, and after some time, you find that they have lost their items. Why? Because they did not measure the resistance per centimeter. So when current is too much, it means that it will spoil everything. So that one is electricity, and it is under the Ohm's law. So as you are revising, as you are making your revision, make sure that now those areas are really of focus. Because the few months you are remaining with, you must be well conversant with those areas. Now, what are some of the real life practicals that we can have? One of them can be under weights. And this one requires the use of the principle of moments. I'm just giving a few. Another one can be around the relative density and density. That one can be around purity, when you want to get the purity of substance. When you want to find, take an example, you want to find out about oil, you want to find about cooking oil, paraffin, and other sample materials. When you want to find out about purity, milk, and the rest of that, we use relative density. When you want to find out whether people are putting water in milk or not, so that kind of it is relying around the relative density and density. When it comes to focal length of the convex lens, this one is very important when they're determining which eyeglasses they should give to a person, whether they should give him this or whether this. So that one is about focal length of the convex lens. When it comes to application of mirrors, you have seen them in salons, you have seen them here and there, then you need to know where are they being applied. When it comes to resistivity and resistance, here I've told you when it comes to connections, when they are making those electrical installations, when they're installing maybe ovens, when they're installing those things at home and the rest of that, the fridge, those wires they use, they must first know about the resistivity before they make any kind of connections. But these are some of the topics. I've just given you some of the experiments I think you have looked at in your schools that you need to be knowing and how they are being carried out and how are they related to your life. So here I'm just giving you directly the way it is they have given them to you at your, but now for you, your task is to relate it to real life. Then we have what we call the steps. When you are going to make an investigation, when you want to find out more about something, there are some steps you must follow. Scientific investigation follows 6 steps. The first one is what we call the observation. Under observation, you look at the problem at hand. After looking at that problem, you go on and ask yourself some questions. And that one is what we call asking of the relevant questions. They have given you your paper. Look, observe, look at it. Ask yourself different questions. And those questions you ask yourself should be how, what, how am I going to do it? What am I going to do? What do I need? Why am I doing so? So those are the relevant questions you ask yourself. Then 3 is you do what you call an hypothesis. An hypothesis is the prediction of what you expect to get. When I do this, what do you think I'll get at the end of it? that when I put in this, what do you think I'll get? That when I put in a lot of efforts in my studies, what do you think I'll get at the end? That is an hypothesis. So we have what we call a null hypothesis, and then an if, and so always that is what we call a prediction of what might come out after you performing that given experiment. Then afterwards, after you need to have an experiment, you go and experiment and find out what is it that you are going to, what you go, the response to your questions. So that is what we call now experimenting. You go and do it and then see what really happens. Then after getting the results, you must go on and analyze them, and then you make a conclusion, and lastly, you present your report. Now, these 6 steps I've outlined here are the ones that we are going to go through this process. So we are going to go through these 6 steps, and then we see what are we supposed to do when the questions are presented to us during a paper. Okay. Now, I'm going to give you a scenario, and I'm going to ask you to read through that scenario. But let me open the chat. I know people may have some few questions as you read through. Yes, you can read through that scenario. That is the scenario that has been presented to us. I'm just opening the chat. In case you have a question, you can put it in the chat. Okay, that is the scenario I want you to go through. Let me hope. Maybe even we can have a volunteer to read. Any volunteer who wants to read? Okay. Yes, Favor.
Okay, good morning. The scenario is, in a small village, there's an elderly man who enjoys reading newspapers and books. He holds them far from his eyes when he's reading. He explained to a young student that he struggles to see well upstairs. Sadly, children broke his reading glasses, but he kept some broken pieces and claimed they had a length of focal length 10 centimeters. He asked the student to help him get new glasses from the eye doctor. The student isn't sure if it's true, so he has decided to investigate scientifically.
Okay, thank you. Okay, so now that is the scenario that we are going to handle. So, and now this is our task that they have told us to handle. And our task is, you have lens X with properties like the pieces of the odd man's glasses. Check if the odd man's glasses had a focal length of 10 centimeters. If you have been able to interact with people around your community, or if you have been able to move around, you have seen very many men and women having, when they are reading a book, when they are reading newspapers, they always try to put them far from their eyes. Not necessarily that they can't, not necessarily that they want, but because they have some eye defects. And you being a scholar, being someone who has studied physics, it means that now you are in position to help that gentleman, to help that person come up with a solution. So, but what is the problem that those people have? And now we are going to give you the support material. Now, this is the support material they have given you, that they have drawn for you some drawing and labeled some parts. And now they want you to go on and attempt. Okay. Oh, okay. Okay. So this is, and now this is the scenario. Throughout this session, we are going to be working with this scenario. And then I'll give you homework to try the one of electricity, to try another one for mechanics. But now the section we are heading, please, I want you to be able to listen very well. Yes, make sure you listen very well such that you can learn, because this is where my focus is for today. One is what you call the aim of the experiment. Now, we are writing the report. So those people who are summarizing, we have started making the report. Things you are supposed to present on your paper. The first one is what you call the aim of the experiment. is the first thing always you must present. So when it comes to the aim of the experiment, there are some key things or some features that are supposed to appear as you are stating the aim of the experiment. This is the experiment that we have been given. So when you are stating your aim, which key things are you supposed to state? One, your aim of the experiment will always be obtained from the task. Always look at the task that has been given to you. That's where you're going to find out the aim of the experiment. The aim of the experiment defines the purpose, defines the objective of carrying out that given experiment. It outlines what the experiment is trying to achieve or to discover. It gives you the direction and the focus. It answers the what and the why. So that's what we call the aim of the experiment. So for you to obtain it, you must come to the task that has been given to you. That with properties like the pieces of the, check if the odd man's glasses had a focal length of 10. Now, this is where you must obtain your task, the aim of the experiment. But we have said it must be clear and concise. It must define the purpose. Why are you doing the experiment? What is the reason for you to carry out the experiment? What do you want to find out? So the what and the why must be answered. So your aim should answer the what. What are you doing that I'm finding the focal length of the lens? And why are you doing it? I want to check if the focal length matches with what the gentleman wants. So that's what we call the what and the why. The what is the focal length is what you want to find out, the focal length of the lens that has been given to you. And the reason and the why are you doing it? Because I want to check if that focal length matches the old man's glasses, the pieces of the glass the old man provided. So when you are stating, make sure the what and the why comes out, why you are doing it and what you want to find out. So that's what we call the aim of the experiment. So the keyword is what and why. Once you answer those two, it means that you have stated your experiment correctly, and therefore you deserve the 2 marks. So the experiment, the aim, will take 2 scores, meaning that if you don't answer the what and the why, in case you only answer to find the focal length of the lens, that is what you are doing. Meaning that one, you deserve 1 mark. You deserve 1 score. So that one, someone will give you 1 score to find the focal length. If you just write find the focal length of the lens X. So here your score will be 1. But if someone answers to find the focal length of the lens X, such that we can find out whether it matches with the old man's glasses, you have answered the what and the why, and therefore they can give you the 2 maximum scores that are given to the aim of the experiment. However, if you miss out on stating the aim of the experiment, then you qualify to get a score of 0. Please take note, here you can get a score of 0 should you not answer or should you not mention the aim of the experiment. So someone will give you if that one is not seen. So whenever it is not seen, then it will not be given to you. So now for such a question, how can I state my aim of the experiment? I've given you here 3 samples answers that you can state. 1, you can say to determine if the lens X has a focal length of 10 centimeters, similar to the focal length of the lens in the old man's glasses. When you look at this one, this part I have given you, I have answered the what. What I'm doing is to find out the focal length. Why am I doing it? Because I want to ascertain whether that focal length matches with the old man's eyeglasses. That is what we call now a clear aim of the experiment. Another one, someone can write it like that. To determine the focal length of the lens X provided, to check whether the old man's glasses had a focal length of 10. You can as well state it like that. So those are some of the ways you can state your answer, such that you can be in position to answer the what and the why. Hope I'm clear on what we call the aim of the experiment. Let me take on one hand. Yes, Prima.
Teacher, when you're writing your experiment, before you do the aim, is it a must to put the title?
The title for the report? It's not
Yes.
a must. Yes, it may not be a must. It is not a must that you should put a title. But to be a very organized student, you can write that a report. You can just put the report. You can put the word report. But for us, we are interested in physics. So no mark is going to be given to you for writing the report. But answers or the scores are going to be awarded starting from the aim of the experiment. That's where the marks start from. Okay, let me hope now that one is very clear. Okay, we go to the next one. So please, that's how we state the aim. Number 2 is what we call the variables. Now, as we did into variables will take about 3 marks or 3 scores, a maximum. What do you need to know? So these are some of the things you must maximize as you are answering. A variable means something that can change, something that can vary. Variable comes from varying, things that can change. That's what we call a variable. As you're working out on this experiment, there are some things that can change in the process. And we have 3 types of variables. The first one, we call it the independent variable. In simple terms, I can call it the IV. So when I write I and V, I'm referring to an independent variable. But don't write it in the paper as you are attempting. I'm just using it for abbreviation. That IV means an independent variable. And an independent variable is a variable that you alter as a person doing the experiment. As you're working out the experiment, you as a person working out, that value for you keep on changing is what we call the independent variable. And when it comes to an independent variable, that one we always write it to the left. It is the first variable we write in our table. When you are making your table of the result, that is the first variable, or that is the first, let me call them letters. We use the letters X, Y, Z of the alphabet. So that is the first one that you keep on or that you are going to write. We call it the independent variable. Yes, Maja. Okay, so that is the only variable that you change as an experimenter through the experiment. That is the one that where you have the control of, yes, it's the one that you can only change. Okay, I continue. The next one, we call it the dependent variable. A dependent variable is the one that is measured. That variable that you are going to be measuring to determine the outcome of the experiment is what we call the dependent variable. This variable is always measured for each change you make in the independent variable. Whenever you change an independent variable, this dependent variable will have to change. So that variable, we call it the dependent variable. So you'll find at times I can call it the V. So when you find the V, it means a dependent variable. Now I want to break them. An independent variable is a cause, and a dependent variable is an effect. So I can call it a cause effect. Now, what happened is that, take an example. Let me talk about cause. Alcohol is my cause, is the cause, taking alcohol. And the effect, leading to school dropout. So the independent variable is alcohol, then the dependent is dropping out of school. That when you take alcohol, chances are high that you may drop out of school. So the cause is taking alcohol that is making you to drop out of school. That when you cheat in exams, what will happen? You will be dismissed from school. That cheating is the cause, and the effect, the feel you are getting, the pain, is you being dismissed from school. So an independent variable is something that causes the change, and the effect is the dependent variable. Yes, Sensuga Umar. Nsubuga, unmute.
Master.
Yes.
Master.
Yes, please.
Asa mbadde mbuuza nti independent variable so ziyita causes ziyita independent just take out the causes.
Causes. Oh, now when
And
you
which
use no, you can't. Now I'm using causes for purposes of understanding. Causes is more or less like English, eh? Yes, it's more or less like English. So I want us to use the scientific word, which is independent. But because I want you to understand, that's why I'm telling you can call it the cause. Yeah. Yes, Global Eden.
okay, Master.
Thank you, sir. Morning.
Morning.
I would like to request those students who are here listening that we are different people who are attending from different parts of the country. So in case one has a question, may them express themselves in English for the matters of interest for everyone to understand. Thank you.
Okay. Thank you, Guru. Okay. Yes. So Nsubuga was asking whether we can call the independent variable, whether we can substitute it with cause. And I was saying that when you use the word cause, you are more or less like using the English word, yet we are carrying on a scientific investigation. So cause, you can use it when you are doing research in the humanity fields. But when you are doing in scientific fields, the best word can be the independent variable. Okay, so when it comes to the dependent is what we call the effect. So hope you have understood that the cause and then the effect. Let me say, if the effect of dozing in class is you may end up not understanding in class. The effect of spending a lot of time on your phone, a lot of time, is you may lose your sight, you may, your mental memory may be affected. So you having a lot of time on screen will affect your mental thing. So the screen thing is what we call the independent, then the dependent is what we call the outcome or the result that comes. However, we have what we call the control variable. We have those things that we can have control over. A controllable variable is that one whereby, let me put it like that, is that variable that may affect our results of the experiment. And therefore, we need to always control it. An example I can say, I used alcohol and I used the effect of it, that is dropping out of school or taking those drugs that some kids take that you may end up dropping out of school. But we have a control variable we can use. Take an example. What do? You limit, if at all you're a parent, you limit the pocket money, because it might be the too much pocket money that you give to this child that makes him or her go buy alcohol and therefore is dropping out of the school. So the control variable is the money you are giving him. Now, if we are doing the scientific investigation, let me say we are talking about, you are doing experiments in light. You may find out that in order for you to see the object clearly, you need to reduce on the amount of light entering into the laboratory by using maybe a soft cloth, and you cover the window such that light is limited from entering into the laboratory. So those things that you can control, those things you can do such that they can limit the effect they may have, are what we call the control variables. And therefore, in order for you to obtain a fair test and a valid test, you must always have control over those variables. Otherwise, if you do not control them, your results are going to be unreliable. Your results are not going to come out as they are supposed to come out. Another example I can give you about the control variable is, many of you use phone chargers. But what happens? You'll find someone putting a phone charger in the socket for the whole day. What is going to happen? The charger is going to heat up. Why? You'll find that the temperature of the wire or of the electric components increases as current passes through. Whenever you connect your charger into the circuit, current passes through. And therefore, whenever current is passing through, it means that the temperature of the wire is going to increase. And therefore, you'll fill your charger when it is warm. So that warmth is the increase in the temperature. So, but we can control that one to avoid our chargers from overheating. Even those people who are using laptops, when you leave it there in the socket for a long time, you'll find that it is warm, but because of the too much current that is going through it, so the temperature is increasing because temperature affects our results. So what will happen? In order for you to control that thing from heating up, it means that you need to switch it off. So that same thing is going to happen when you are doing electricity practicals. That when you have connected your ammeter, you have connected your voltage, you have connected other bulbs and the rest of that. Whenever you are making a result, whenever you are carrying out a result, you must switch it off. Otherwise, once you leave it on, you take one result, you leave it on, you start calculating. You leave it on like that, the temperature is going to increase in the wire. And as a result, the results you are going to get are not going to be reliable. So that means you need to have control over it, that whenever you take a result, switch it off. Make your switch off such that you get reliable results. So that is what we call a control variable. You must have control over it. You are carrying out an experiment, let me say about swinging, about the pendulum bob, about what? And you find that there is a lot of wind blowing. As a result, your things are going to be blown away. You will not obtain accurate answers. And that is one of the reasons as to why very few of you have ever managed even to balance that meter load. The reason is because of the air resistance. That whenever you're doing, there is some air resistance, which is we call the friction. So you can never have that meter load balance well as long as you have those things not controlled. So air resistance or the wind can be controlled by maybe closing the windows. Some of you even have fans in the laboratories, you leave them on. So as a result, you cannot have. So that's what we call the control variables. Okay, I'm going to continue. Yes, let me take one hand from Samuel. I can take one question. Yes, Samuel.
Okay, good morning, Master.
Yes, good morning.
Can I abbreviate this control variable as a CV?
Yeah, okay, abbreviating is okay, but when you are making your report, do not use those initials. You can only use it here when you are summarizing for the purposes of understanding. But when you are making a report, write it as control variable, dependent variable, independent variable, like that.
Okay, Master.
Okay, yes, Anne.
Yeah, like you've spoken about air resistance. I'd like to know if I can call it also wind. Is it okay?
Oh, okay. Okay, you can call it, okay, you can use wind. You can use wind. But it will depend on the experiment you are making. Yes, but air resistance, we are looking at the opposition. Okay. Yes, KG?
Yeah, good morning, sir.
Yes, good morning.
I have an inquiry about the control variable.
Yes.
In some books, it is called a controllable variable. Is that right?
Yes, that one can also be okay, but better you say a control variable. Oh, okay, controllable. Controllable means it is also fine, but the best can be control variable because it is you who is going to control it, not someone else is controlling it for you.
Okay, sir. Thank you very much.
Okay. Samuel?
Thank you, sir. Good morning.
Good morning.
Could I call the control variable the same as the constant variable?
Control variable is the same as?
Constant variable.
Okay. Now, it will depend on the books you are reading, but when you talk about a constant variable, it means something that is not changing. Constant is not going to change. But let me take an example of wind. Wind can be a little small, a little more, so it can easily change. So it's not constant. So that word is not clear, much as some people may use them. Or at times even you may find books using fixed. Yes, but the best word is control. So you control depending on how much is coming in. That in case now the room has little light, then you may block a bit of it. In case the light is too much, you may even find yourself putting a lot such that the room is darkened. Ambrose.
Well done, sir.
Thank you.
Mine is about the control variables. So can't you be doing an experiment and you find that in that very experiment, there are no control variables?
Okay, I'm going to talk about it, but for every experiment, there is something you may need to control in every experiment, but I'm going to show you. That's where we are heading. That's where we are heading.
Okay, sir.
Okay, yes, but for every experiment, there is something you have to control over. Okay, the rest kindly allow me to first continue because it has started to threaten train where I am. Okay, then we are going to look at how do we identify those variables? How do you identify the variables? In order for you to be able to identify the variables, one is using the formula, is you knowing the formula to use. Two, looking at the aim of the experiment. And now this is where I'm going to base my attention. The moment you understand this, it means the moment you understand the three variables, then it means you are going to be in position to answer every other part that is going to come. One, now I'm starting. We have what we call the independent variable. The independent variable, like we have said, is the one that you control. When we are performing this experiment of light, our control we can have, what we can do for this experiment, what we can do as experimenters is to measure the objective distance. That's what we can measure. That's what we can do. So it means that for us, what we shall be doing is we get the objective distance, and then we can keep on moving the screen. Now, for this experiment, it means that what we are going to do, what is our independent variable, is going to be the objective distance, the distance from the wire goes to where the lens is. Then, the independent variable, whenever we change the distance of the object, that maybe I have brought it very close here, what changes is the image distance. And therefore, the image distance is what is going to become our dV. Our IV is the object distance. Our dV is the image distance. Because any change you make in the objective distance, it means that the image distance will have to change. Now, what about the control variables? Now, that's where I'm going to concentrate. And here I'm going to rotate in three topics. I'm going to rotate in mechanics, I'm going to rotate in light and electricity. So please pay attention. Now, in our syllabus or in the syllabus, they do not specify, or you are not supposed to, the formulas for, let me say, for lens, they just mention it about the lens formula. However, when we come to practicals, you must know the lens formula. And the lens formula, how does it state? It says 1 out of F is equal to 1 out of U plus 1 out of V. Now, this formula applies when it comes to meters. So I'm going to beat two birds at the same time. You are going to use it for lenses when it comes to lenses. This formula here. And we know that F stands for the focal length of the lens or the mirror, depending on what you are doing. U stands for the object distance, the distance from where the object is to where the mirror is or the lens. Then V stands for the image distance. And if it is, yes. Now, how are you going to come up with the control? How are you going to come up with other variables that you may need, or what we call the independent variable? Sorry, the dependent variable. Remember, the dependent variable, I've only mentioned V, but it's not only V. So there are other variables that must come in. So how do I bring them on board? I'll get those variables from the formula. So how am I going to do? One, we must express our formulas always in the form of y is equal to mx plus c. In senior 4 term 1, you always cover equations of lines. You cover how to make the subject of the formula. So we are going to express all the equations in this format of y is equal to mx plus c. So I'm going to do the mathematics. So I will say 1 out of f is equal to, here when I look here, my LCM is going to be uv. So what am I going to do? I will say uv divided by u, I end up with v, plus uv divided by v, I'll end up with u. So I'll have 1 out of f is equal to v plus u out of uv. Let me hope now you are following. We are doing now the mathematics such that we come up with the different formulas. Now, after doing so, what do I need? I can now do the cross multiplying. So the cross multiplication, I'll have uv, I cross multiply, I cross multiply. I have uv is equal to v plus u, then times f. Now, what am I looking for? We are looking for the focal length. So now, when you look at this equation, I can come and I relate it to y is equal to mx plus c. Now, if I'm to relate it to y is equal to mx, I can even write it in another better way as uv is equal to f into v plus u. It is the same thing. So now this one, I can call it my y is equal to mx plus c. Now, when I'm relating these variables, one, y, I'm going to relate it to uv. I'm relating it to this. Then m is the gradient. Gradient, I'm going to relate it with this. And to obtain gradient, you obtain it after you have plotted your graph. Then x, I'm going to relate it to v plus u. Then my c is the intercept. Since this equation I have made the subject doesn't have anything here, it means that my intercept is 0. Meaning that in my form of y is equal to mx plus c, I'll have my y as uv. Then I'll have my x as v plus u. Then m stands for gradient. My gradient m will equal to f. Meaning that when you plot your y against the x, the result you get will be giving you the line, and that line will give you the gradient. But you have noticed that the intercept is 0. Meaning that when I'm plotting my graph, it means that along the y-axis, because of my y is uv, I'll have uv. And I'll plot along my x, I'm going to plot v plus u. After plotting that, I'm going to get my line, whereby the intercept is 0, meaning that line will pass through the origin. So I'll come and I obtain my slope. So this slope I get will be equivalent to the focal length. So what are other independent variables? Other independent variables, I'm going to get them from the formula here. Now, from the formula, we have obtained uv, we have obtained v plus u. So that means that, and what we are plotting, all these ones are there. So I'm going to say that my independent variable, one of them was going to be v, then I'll have v plus u, and then I'll have uv. Those are going to be, these are dependent variables. So the dependent variables, I have v plus u, and I have uv. So all those parameters that you are going to get from your equation, you include them under your dependent variables because all of them are depending on you. V is depending on you. V plus u is depending on you. uv is depending on you. So that's how we obtain other dependent variables. Okay, I take one question. Yes, Liz.
Teacher, I am really lost. Can you please help me and repeat?
Where are you lost from where?
The formula of y equals to mx plus c.
How I'm relating it? Oh.
Yeah, how you are relating it.
Okay. Did you understand how we made the subject?
Yes, please.
Did you understand how we made it the subject? How we made the subject of the formula?
Yes.
Okay. Now, what you do is that your y, our y is equal to mx plus c. What do we want? We want to find out what are we going to be plotting. And m always is your gradient. So your gradient should aim at getting for you what you want from that experiment. So what we want from that experiment is focal length of the lens. So the focal length of the lens, when you look at what we have here, it means that the variables that are with f are going to be forming our x. Then the variables without that, without the f are the ones that are going to be forming our y. So when I write it, I say y is equal to mx plus the c. So since m and f, they are in the same position, I can say that my m is equal to f, my gradient. Then the x and the v plus u, this one I'll consider it as one item, one thing, one expression. So my x will equal to v plus u. Then my y will equal to u v. So this is one approach. This is one way of deriving, but there are other ways. Let me show you another thing. Another approach you can use, I don't know whether Virus has a question. Oh, the questions are many. Let me pick two. Yes, Musa. Okay, Musa is not talking. Elijah. Yes, Musa, go on.
No, Kazib, I have a concern.
Yes.
Good morning.
Morning.
Thank you for conducting this session, and I've been following from the start. We are at a point of identifying variables, and you clearly said that whenever we alter, like for this experiment, whenever we alter the object distance, what directly depends on you is the v. So in writing the report, we started from the aim or the aims. Now, after getting the aim, we are identifying the three variables.
Yes.
Now that we are now identifying the dependent variables. How do because now the dependent variable for this case is the image distance. But you are saying that even if v plus u depends on you, that is very true. But how can you write that v plus u? Because at the state of our report, we have not done the procedures. The formula has not come into play yet. So are you trying to mean that in identifying other dependent variables, you said that object distance plus image distance is also dependent in the report, in the real writing of the report, because it is beyond doubt that they are dependent. But how can you write them in the report?
Okay, now in the report, we have, like when you are writing, you will not write only you, because I'll write my report, I'll say object distance. I cannot write you. I will write dependent or independent variable. Then I say objective distance u. I write independent variable, image distance v. Then I can add, since I've already mentioned objective distance u, I've already mentioned image distance v, then I am free to write u plus v and u and v.
I can get you now.
Yes, since I've already defined them. Okay.
Then still, Kaziba, you need to increase on the speed, because the session is so good, but we have other engagements.
Okay. I think those people with questions, allow me to, I will be picking just one question from each from whenever. Yes. So allow me to, but in case you do not, then I'll come in again. Now, these formulas will always depend on how you are going to carry on the experiment. Take an example. In case this is how your experiment was given to you, then you need now to first identify which formula to use. So I'll come and I say that I will first identify my independent variable. I will write independent variable. I will say object distance. Now, for this case, we know that object distance is that distance from where the wire goes is, because the wire goes acts as our object up to where the length is. So I write object distance, then I put comma x. Then I write dependent variable is the image distance. However, now for this case, you must be very careful. Why? Because the image distance, or what is going to change here is the distance of the image. So for this case, it can be y, because whenever x changes, this distance of y is going to change, because the one that is forming the image. But how are you going to identify other dependent variables? So you come back, you say 1 out of f is equal to 1 out of u plus 1 out of v. Then you ask yourself, I want 1 out of f is equal to 1 out of u. Your u is the object distance, which is x. So I write here x plus 1 out of v. But what is v? V is the image distance. And the image distance is always measured from where your lens is up to where the image has been formed. This distance here. But it has not been given to you directly, meaning you must know it. So the distance from here up to here is given by y minus x. So I'll come here where there is v. I'll put y minus x. So I'll continue and I say 1 out of f is equal to, allow me to do quick math. I will cross multiply. I'll have y minus x plus x out of x into y minus x. Like students, you just cross multiply. For me, I just use that cross multiplication approach, or you get the LCM and then you continue. Now, when I reach here, I'll have 1 out of f is equal to minus x plus x is 0. So I get y out of x into y minus x. Now, here, I can go on and I say I'll plot this out of this, which is okay, but it may not look so nice. So you can continue on and simplify. Hope you know that you can now come here and I say I can cross multiply. So I'll have x into y minus x is equal to y f. So when I open the brackets, I get xy minus x squared is equal to y f. But what do I need? I need f. So what do I do? Now, in case you want, you can even go on at this step and you make one of them the subjects of the formula. So now it depends on what you want. It depends on what you want to make the subject of the formula, such that you can like reduce. So so if that's what you want, that you can do it. So another person can decide to say, I divide by y, I divide by y, I divide by y. So if I divide by y, it means I'll get x minus x squared out of y is equal to my f. So if I decide to do like that, I can take the negative x that side, so I get x is equal to f plus x squared out of y, which I can arrange it at x is equal to x squared out of y plus f. Now, why? Because I want to have my independent variable alone, to stand alone. And if I want to have it stand alone, I can come now and I say, this is my y is equal to mx plus c. Now, for this case, it means when you write it in this case, it means that your x, your object distance x that you are getting, that you are doing or that you are working with is your y, is what you are going to plot along the y. Then it means that your gradient is going to be 1, and your x, what you are going to plot on your x is going to be x squared out of y. Your y, you are going to plot your x. And here, your intercept c is going to be your f. So your c is going to be f. Meaning that for the graph that you are going to draw, the intercept you are going to get, let me say the intercept is here. This one is going to be your focal length. So do not cram. You must understand how to deal and come up with the formulas. Now, for such a case, it means that when you are writing your dependent variables, it means that now you will say, I'll have x squared out of y as part of my dependent variables. Okay, allow me, I may not, you want me to take one hand. Okay, Julius. Julius? Okay, Julius is not talking.
Yeah, thank you. Thank you. Thank you,
Yes.
sir. I would like to ask you, for me, I have not answered this for the second formula, sir.
You have not?
Understood this second formula.
Okay, now the second formula, it depends on how the experiment has been arranged. But what we are playing with here, we are playing with the mathematics of making the subject of the formula. Always, if you are trying to find out what to plot against what, always better you make your independent variable the subject of the formula. You make it stand alone. And then you may not make it completely the subject of the formula, but you make sure it stands alone. And then you express it in terms of the equation of a line. But allow me, but here for this one, please do not worry, dear students. Your teachers are going to expand on what we have done. But I want to just give you just a clue such that you can build up from there. Okay. So allow me to move on because I want us to look at it. Another example I can give you is here in mechanics. When it comes to mechanics, now here I told you one of the experiments I showed you was about moments. And we know that when it comes to moments, always we know that the clockwise moment will always equal to the anti-clockwise moment. That is the principle of moments. Meaning that when you find such experiments, you need to have that idea. Things that involves balancing a knife edge. Just the idea that should be on your hand, on your head, should be about moments. Even they can bring it when you are balancing a ruler in space using a retort stand. All that one is moments. What do you need to remember? We know that moment is the product of we are going to have, you balance the what? The formula, the clockwise moment times the anti-clockwise moment. But what are you going to do? We know that if I have this is my mass M, let me say this is the known mass, I can call it M. This is the distance D1, this is D2, and this is the empty bottle whose mass they want us to find. So allow me to call the mass of the bottle MB. Now, what do I want you to do? We want to identify which other dependent variables shall we need. Then I'll come and I find out what am I going to be plotting, because what you are going to be plotting is what determines which other dependent variables you are going to include. So I'll come, I say the mass times D1, MD1 is equal to MB times D2. Sorry, I'll write it as MB times D2. I'm applying the moments. So here, I can come and I say, because when you look here now you need to reason. What is varying? You are not seeing that whenever this known mass, whenever the mass here changes, whenever it changes, or this distance will change, and this distance will also vary. So the two things that are varying is the distance D1 and D2. They're the ones that are changing whenever because you need to balance the ruler. So whenever they change, this side changes, the other side will have to change. So now I can decide to make my D1, because it is a varying variable, is equal to MB out of M times then the D2. Since I've already identified that D1 and the D2 keep on varying whenever I am changing, whenever I change the mass, whenever the mass is different, then I can say that this is Y is equal to MX plus C. What is happening? That D1 is going to be my Y. So along my Y axis, I can plot D1. Then I come here. M stands for the position here. So the whole of this one is under the M. So I will say that my gradient or my slope is MB out of M. Then my X is equal to D2. And therefore, I know that other variables that I'm going to include can be MB out of the M, whereby MB is the mass of the empty bottle. So now I will know when I come to, after making all other things and the rest of that, I'll know that MB out of M, I know that M is the slope. So in order for me to get the mass of the bottle, I will just multiply M, whereby M is that these are the known masses, times M, which is here the slope. Allow me to say now slope is equal to M of the bottle out of the M of the known masses. So I cross multiply, I'll have the slope times the mass of the known bottles should give me the mass of the bottle. So here we are applying the moments or the principle of moments. So for the known masses, here you can get their average. In case you have used the very many of them, you can get the average of those masses, and then you make that calculation. So that is about now mechanics. Now, what about when it comes to electricity? Now, when it comes to electricity, here the common law at your level they can bring is what you call the Ohm's law. We know that Ohm's law states that V is equal to pi R, whereby V is the PD or is the voltage that is measured by the voltmeter. I is the current that is measured by the ammeter, and R is the resistance. So at this level, they can also ask you to come up with to a number. Okay. Allow me to take some water. So they can ask you to come up with they can come up with an experiment like this one I've showed you. And here, they can ask you to have the relationship between resistance and the length of the wire. You know very well, like I told you, during connections, those wires differ. Any kind of connection, you can't use the same wires. So those wires keep on differing depending on the resistance and also what you want to do, or what you call the resistivity per meter and the rest of that. So now here they can ask you to have to show or to find out which kind of relationship exists between the resistance and the length of the wire. Have you ever asked yourself, when you look at the electric poles, those poles that they use, they keep on breaking them. One wire, they keep on breaking them, like that kind of breaking. Because they don't want to have one long wire. Then that one can be the theory behind someone is targeting. Do you know why? So the idea of that one will come from the Ohm's law. So they can ask you, what is the relationship between the resistance and the length of the wire? I will show you a sample question on that. So now when it comes here, what do you need to know? One, you need to know, I must express my equation in form of y is equal to mx plus c. And what does the person want? That I want you to have a relationship between resistance and the length of the wire. So what am I going to do? I'm going to come here and I say, how do I get resistance? So I will say resistance is equal to V out of I. Meaning that when I'm drawing my table, since I want to find the relation between resistance and length, I'll have my length. This is going to be my independent variable, because for whenever the length changes, the value of voltage and the ammeter reading will have to change. So I'll have I as part of the dependent variable. I'll have V as part of the dependent variable. Then I'll have V out of I as also part of the dependent variable. So V out of I is what gives us what? Our resistance. So then that means I'll mention all the dependent variables. So I'll mention I, I'll mention V, I'll mention V out of I, because all these ones are part of the dependent variables, because all of them, they depend on length. Whenever this length changes, the ammeter and the voltmeter reading will have to change. So now that's how we get to know what are the independent variables and what are the dependent variables that I must include when I'm making my report. So hope I've showed you a sample for all the three sections that you must know: the heat, the electricity, optics, and then the mechanics. Okay. But here as well, there are other experiments that they can ask, such as about resistivity per centimeter. That one is very common because it is a good application whenever they are connecting electrical appliances. They love it. But that one, the teachers, I think they can help you to learn about how to find that one. But we use the resistivity formula. But for more mechanics application formulas, for the teachers who may be on the call, please go on and look through simple harmonic motion. Many of those formulas within simple harmonic motions are the ones that we apply into for mechanics. Many of those formulas keep on applying, but they come from simple harmonic motion. That is for only the teachers. So you can go and pick an idea from there, and then you can help your students out. Okay, then so for this particular one, what would be the best way to state our variables? So the sample answers, I just used an abbreviation, but please, for you, go on and use the what? Go on and use the full one. Variable. Then I can go on to state the IV. I'll say the image distance V, U plus V, and then the UV. Then the image distance V from the lens to the screen. Okay. 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 Then the next one is the control variable. Now, whenever we are carrying out light experiments, what are some of the control variables? We have things, in order for you to see a clear image, you must have a minimum amount of light into your room. Whenever that light is much, you may not be able to see that clear or that sharp image. So one of the control variables is you must control the amount of light, is one of them. That is one of them that you must control. But here we can have other things you can control. One is the parallax thing. Parallax. Yes, parallax is like the position, how you position your eye when you are reading the values on the meter rule or on any measuring instrument. It's another variable. There you have not included it, but it is part of it. Okay. Then I'm going to go to what we call the hypothesis. Now, when we talk about an hypothesis, please, now we are writing our report. The first one, we talked about the aim of the experiment. We have gone to the variables, and I've showed you how you present your variables. Here, the control variables, put as many as you know. I've told you here you can include the parallax as part of it. Okay. Then, but that one, then I look at the hypothesis. Now, when we talk about the hypothesis, is a statement that gives you a tentative answer to the solution of your problem. It's more or less like a prediction of what can happen when you carry on that experiment. That maybe when I carry on this experiment, I may find out that the focal length is 10 as the man was claiming. So the hypothesis will always come from the experiment and always look at the task. But what are some of the features of a good hypothesis? One, the hypothesis you come up with must be the outcome of the experiment. It should be testable. You must be able to carry it out. If it's not testable, then it's not a good hypothesis. So a good one should be tested. So remember, we have two types of hypothesis. We have what we call the null hypothesis, and we have what we call the no difference hypothesis. But for our scientific investigation, more so in science, we deal more with what we call the no difference hypothesis. The null hypothesis is mainly used in the humanitarian kind of research, but also here it can apply, but mainly in chemistry and biology. But in physics, we shall concentrate on the no difference hypothesis. Okay, now here I've been a bit brief. I have just showed you how you must state your hypothesis. So it must be testable. So this is the sample of how we can test for hypothesis. You can just say the focal length of the lens X provided is 10 centimeter, which is the same as the old man's glasses. So this is what you are going to test, whether it is really true. Is it 10? And please never commit yourself to go on and mention, because you may say, I know the type of lens. It is this type of lens. It is convex. It is what? Please do not commit yourself if even you are not sure. for you just use what they have used in the question. Once they tell you length X, continue using length X. Do not commit and say, I know this one is called a convex lens, that the focal length of the convex lens is 10. No, please do not. Always, for you, you must just keep on using what they have given you. That, I know this mirror is called a concave mirror. I know this mirror, this lens is called a what? A converging lens. Please do not commit yourself when you are doing so. So this is what we call the hypothesis, and I've given you a sample of how we state them. Okay. Okay, I think, let me take one hand. Katatumba, Ribad.
Okay, I have two questions.
Yes.
No, two concerns, yeah. So can you have a wrong hypothesis? Let's say if the focal length is not actually 10 centimeters.
Yes, now for such, you can give a range. You can say the focal length of the lens is maybe, you can assume is provided is around, maybe you can give a range maybe between 8 and 10.
Yeah, and another thing. Okay. Another thing, there's this guy called Samuel. He was asking a constant variable. Well, I wanted to ask, how can something be a constant variable yet the word variable itself means to change? So yeah.
Oh, okay. Okay, thank you. Thank you. Okay, the last one, virus. Okay, I think I'll finish. Okay, I think let's continue. Others, I will open the chat and we shall answer those questions. Kindly allow me to proceed. Okay. Now, the next section is what we call the list of the apparatus or the materials to be used. One, ensure that you list all the apparatus that you are going to use for your experiment. UNEB is tricky. At times, they may give you apparatus that you are not even going to use. And for you, just go on because you crammed or you put everything you have in the report. No. Please and please make sure you only put the materials or the apparatus that you have used when you are carrying, or the things you think you are going to use when you are carrying out your experiment. Because when we are awarding for when it comes to apparatus, one of the things is stating all the relevant materials. Now, that one is 2 scores. Stating partially some relevant, that is 1. No apparatus stated, that is 0. So if you state things and that are not relevant, then they can deny you the 2 marks and they give you just 1 score. So you must state things that are relevant. So only state things that you are going to use or things that you feel are going to be needed in that particular experiment. 2, give the quantitative value of the apparatus. Quantitative, we mean the number, the digit, that how many that I'm using 1 meter load. So mention 1 meter load. That I'm using 3 maybe connecting wires, 3 connecting wires. I'm using 1 ammeter, 1 voltmeter. So that's what we call the quantitative value of the apparatus. Now, we have some common apparatus when it comes to mechanics. Please do not risk to go if you don't know how any of these ones work. These are some of the common ones we have. Mostly when it comes to measurement, it can be a beaker, it can be a measuring cylinder. So you must know how they work. A stopwatch, a stop clock, vernier caliper, micrometer, screw gauge. All these ones are part of the measurements that you did in senior 1. Okay, I'll continue. When it comes to light, these are some of the common ones. So when I'm mentioning, I will say one cell holder. But now this one being a single, I specify a bit specific. 1 single cell holder, 2 connecting wires, 1 lens holder, 1 lens labeled X, 1 mirror, 2 torch bulbs, one dry cell, 2 pairs of dry cells. So that's how I state the apparatus I'm going to use. When it comes to electricity, these are some of the common ones that we use when it comes to electricity. But I wanted to just maybe talk about, you may find that wire and you ask yourself, oh, what is that? Oh, what is that? So that wire, I know your teachers may have told you already, or they are yet to tell you, that wire is what we call a constant wire. So that one, take note of the spelling. You may reach there and even you fail to spell it. It's called constant wire. These are the wires that we commonly use in electricity. And we use, for you don't need to specify, but maybe for teachers' purposes, we have what we call a standard wire gauge. And we have 28, we have 30, 32, like that. But this one is not relevant. This one you may ignore it. It's not important because they may not specify for you. But what you need to know is the name. Those small wires you see on your meter rods, we call them constant wire. Yes. And for it, the more the gauge, the more it decreases in the diameter. So the common one we use in labs is 28, is the most common one. Then at times they can use 30, 32, like that. But the most common one is 28. Okay. Then I think I wanted also, there's something I've not thrown light on when it came to mechanics. Okay, but I'll throw more light going forward. Okay. Now, some of the apparatus we use here, I'll just mention them. You just look through and see them. So when you look here, you are noticing we have a switch, so you have to mention it. So those are some of them. And when you look at how I stated them, I was very clear. I said 1 torch bulb, and exactly I was using 1 torch bulb. 1 lens X, this is the 1 lens I'm talking about. 1 meter rule. And now this is why I wanted to emphasize that in case they have given you 1 meter rule, right? In case it is 2 meter rules, you write. But now I want you to get a difference. Here we use a meter rule. Please don't write meter ruler. I know some of you may write meter ruler. This one is something different. A meter ruler. A meter ruler is the one you use in class. A ruler is shorter than a meter stick. So we use a meter rule. Don't write ruler, don't add on R. And also, let us ignore writing this meter. This meter is correct, but this one is more or less of the American English. It's more or less like the American, yet we are colonized by the Britain. So we always use this kind of meter. So we write rule, meter rule, not meter ruler. Okay. Let me hope that is very okay. Now, still, I want you to go on and always include the letters, or include the letters the way they were used on your instrument. Take an example here, switch K, 1 switch, comma K. 1 screen with illuminated wire goes. Connecting wires. Now here, I did not specify, but you specify that 1, 2, 3, that 3 connecting wires. 1 whiteboard screen. In case the screen is white, you write 1, I can just say 1 white screen. So be specific. Be specific and write what has been given you. In case you have 1 meter rule, you have the other short one, please write everything. 1 bulb holder. Yes, so we need to be specific on what we have. 1 double cell holder. So be specific and write. In case the 2 dry cells or 1 pair. Now, like, yes, here you can write 2 dry cells or 1 pair of dry cells. So briefly, that's how we can list the materials or the apparatus for our experiments. So we are on report. We are writing a report. So those who are following, make sure you follow. Now, the next one is what we call the experimental setup. How are you going to set up your experiment? So this is how I've set up my experiment. Now, please do it also when you are doing your report. Because when it comes to experiments, remember you're writing a full report, someone is going to look out for. And your experiments, please, they can be different. You may find someone doing something different, someone doing something different. That's why it is better you include the setup, how you have set up your experiment. Don't base on what you have seen others. This is a competence-based curriculum. All of us can have different experiments and achieve the same. You can decide to go to Kampala using a car. Another person can decide to go to Kampala using a plane. All of you are going to reach at the same destination. So it's not a must that we must always stick to the experiment sample the paper has given us. No, be creative. As long as the materials you have can be used to attain the objective of that experiment, of that particular question, you can create yours and come up with the same thing. But what is important, show the setup, how you have set up yours in the question. Okay, then I'm setting up mine. Be very careful because this is where we are going to develop the procedure. Allow me to repeat. This is how I'm going to set up my experiment. One, I'm going to get my lens holder. That is my lens holder. And then I'm going to mount. We call it mounting, mounting or putting. I'm going to put in the lens. That is my lens. Afterwards, so the first step I will say, a lens X is mounted into the lens holder, the way you have seen me doing. Now, this is how I'm going to carry on the procedures. Yes, I say a lens X is put into a lens holder, or a lens X is mounted into a lens holder. Now I go to the next. Two. Then this is my screen with the wire goes. After, I'm going to go to the next. This is how I'm going to measure the distance from where the wire goes is up to where the lens is. But when I'm measuring, I make sure the ruler is direct onto the screen. Even I measure in the middle of the lens like that. I make sure that is the right measurements. Now, in case my first object distance is maybe you, I'll measure it and I put the 20 I'm getting. What am I going to do next? I'm going to go and I connect my switch and the bulbs. I connect them like that. After connecting, what am I going to do? Because I need a screen in order for me to be able to see the image, I'll go on and I switch on. But okay, that is the switch. After switching on, then I have, that is my screen. So I've switched on the light. Hope you can see the light in yellow. And then what am I going to see? I'm going to be moving my screen, this white screen, until a sharp image appears onto the screen. So when you look at my screen, you can see the sharp image appearing. After that image appearing, I'll come, I measure the distance from where the lens is up to where the object is. And then I record that distance. In case it's 20, I put the 20 there. So now, how I have set up this experiment is how I'm going to write it in my own words. Do not go on and cram that I must do this, I must do this, I must do this. No, do not cram. For you, write the way you have done. However, your procedures must be coherent. There must be a flow. That are they flowing? Don't write things that, a sharp image is obtained. After you say a lens is then mounted. No, that one, there is no coherency. So you must be able to show the flow because the procedures in any experiment, they will be carrying marks. And those marks will be awarded in form of relevance of the procedures. That were the procedures relevant and correctly written, or they were partially. Was there a flow of the procedures? You may write relevant procedures and you get the 2 marks. But you may write them, but when there is no coherence, that one, you miss the mark of coherency. But in case there is some flow, you can get a 1. But if there is no coherence at all, then you will get a 0. So you must have your procedures, set up your experiment the way we are having. Let me take on one question. Kegi. Kegi, ask.
Thank you very much, sir. I have a question about the setup.
Yes.
In one of the practicals we've done, we are given a setup, a diagram of what the setup should look like. And what you mentioned that after setting up our apparatus into what we are going to do, we should also draw that. Is that necessary to draw it again?
Okay, now why I would recommend you including your sketch. One, you are going to remain with those papers of yours. Two, you remain with the question paper. Two, each of you can have a different way of carrying out this experiment. This experiment is not they give you a sample, but for you can decide to do it in a different way, as long as you achieve the objective of the experiment. Like I've told you, when I'm moving to Mbale, or when I'm going to the Western Uganda or where, I can have very many paths I can use. So the paths I can use, I can decide maybe to use a plane. I can decide, let me talk about Jinja. When I'm going to Jinja, I can decide to use, let me say, Mukono, then I go to Kayunga and I go to Jinja. I can decide to use Mukono, Lugazi, Buyukwe, like that. So you can use different paths, but you reach the same answer. Two, so here everyone can come up with his own experiment. It's not a one-way thing that always stick to what they have given you. That one they have given is just a sample setup. But for you can come up with yours, but also that one they have given you, at times even they may not label it for you. And even when you are explaining an experiment, when you are making an experiment, you are explaining something, it is always easier when you are looking at something you are explaining. But if there's nothing you are looking at, then there is no use, or you may not be able to understand. Because you may want to refer to one of the variables, that the distance x, let me say the distance x from the lens to the screen. But when the person marking is not seeing it, how will that person see it? Remember, you have remained with your question paper, and not everyone is using that. So that's why we can include in that experiment you have set up. Yes, the only challenge is going to be now on how you are going to manage your time when you are making your report. Remember this report, just imagine you are handing in a report. The moment you hand in a report, that report must be able to talk about everything you have done and how you have achieved it. So not just someone to assume, maybe the diagram was like this, maybe the setup was like that. Don't make people to assume on your script. Let them see what you are talking about. Okay. Let me, Global Eden Koboko.
Yes, sir. My question is, if you change the diagram, are you not changing the variables now? And yet the UNEB may expect, or the examiner may expect you people to have the same variables.
No.
That is one.
Okay. Now you are going to use the same variables like the question. But when you read the paper, they always tell you, if you have looked even at the samples, they will tell you that other relevant diagrams may be used. Other relevant diagrams, because like I've showed you when it comes to light, what is important is how you are going to achieve the objective of the practical. That is the most important thing. The order of the way you set up your diagram, because like I've told you, in this curriculum, in the competence-based curriculum, it's not a one-way route that everyone must do this, everyone must do this. Even in real life, you must be creative. So if they may make a setup, and when you look at it, I can use another approach to get the same answer, as long as I've been in position to solve the problem.
Okay.
But yes, as long as you're in position to solve the problem at hand, that is what is very important.
Can experiment have more than one independent variable?
One independent variable. Those are very few. Those are very few, and you may not meet any at the moment. Yes, you may not meet any at the moment, whereby the independent variable is more than one. But in most cases, it is always one. And at this level, yes, we shall always have one. The two can happen in mechanics. can happen in mechanics, but those are practicals that are a bit more advanced, but it can happen in mechanics. Okay, allow me members to continue. Okay, so the procedures, this is how I can state it. And let your procedures be talking procedures. Procedures you look at and you refer to the diagram. Like I've told you, that your diagram you have drawn can be able to speak for you. So I will say the lens X whose focal length F is to be determined is mounted into the lens folder. I mentioned the lens and I mentioned the aim. Then I go, the screen with the wire goods is placed at a distance U equals to 20.0 centimeters from the lens. Now, I want you to be very careful. The way I have noted my object distance, I've said 20.0. Why? Because in order for me to measure that distance, I'm using a meter rule. And I know a meter rule has a least count of 1 decimal place. So when I'm recording, I'll write 20.0 centimeters. I will not write 20 centimeters. Why? A meter rule is not written to 0 decimal place. So that's why I write 20.0 centimeters. The least count of a meter rule is 1 decimal place. So you'll be careful when you are. Then I said dry cells are placed in the order. Then I go to the next one, switch key. So I want you to take note of how I'm labeling the variables, of how I'm including. These things are on my what? On my diagram. You can see K is there. You can see where U is. You can see the length X. So let those variables that you have, those letters, those digits you have used on the diagram be displayed in your procedures. Let them be seen. Then the screen is moved to and fro to obtain a clearly focused image. Then the switch key is open and the distance V. The procedure are repeated. Now, this is what I want to emphasize. That when you're writing your procedures, label them. Say, in case you have decided to use A, B, C, D, E. In case you have said 1, 2, 3, 4, 5, 6, 7. Don't just write sentences. Label them. Say 1, 2, 3, 4. Such that when you come to this important part G, where we say are repeated for different values, for any experiment, for you to attain accuracy, to attain the coherence, you need to have more than one value. You can never base your conclusion on only one value and you say, this is the accurate value. No, the reason as why we do experiments, because we want to have as many values as possible such that we can have a big idea on where we are on the accurate things. So when you are making your experiment, make sure you repeat it. Don't just say, I have done one value and that is enough. One value can never make a good conclusion. You cannot see someone the first day and you conclude that, this person is bad. You have only met the person once and you say the person is bad. No, it is not, it's not true. So that person may be bad on only that day, but it can be good. So the first value you attain may be inaccurate, but the values you attain after, they can be very correct. So always make sure you make at least 3 variables, 3 values. Repeat the experiment for at least 3 values, such that you attain that accuracy. So you cannot that I'm writing my things as yes. So this is a comma, 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 like that. So I write 30.0, 40.50 like that. So please, at least, I've said at least 3. Make sure you repeat the experiment for at least 3 other values. But the best can be 6 values. That's when you can have a good judgment. If you meet someone for 6 days and this person is doing the same thing, then you can be right to conclude that this person is a good person. If I meet you reading on 6 consecutive days, then I can conclude that this student is serious. But if I meet you once, I can never conclude that maybe you're a serious student. If that maybe that can be your first day into that class. So please make sure you get at least 6 values or more. Okay, good. Then you do the tabulation including the values you want to plot. And then show the graph, and then the slope, the focal length, Yes. So that is a simple procedure. You be concise. Use simple language. Don't use those English vocabularies of yours. Very, very hard work. But make sure your procedures talk. Let them walk the talk on what is on your diagram. Don't not mention things that someone cannot visualize when it comes to your diagram. Let me take on one question. Rory.
Yes, teacher.
Yes.
I wanted to ask, like, where can the experimental setup diagram come? After which procedure? Oh, it's before the procedures. Thank you.
Yes. Okay. Now, that one you can have it before the procedures, such that by the time you talk about your procedures, someone can look at the experiment and sees the procedure. So the experiment can come first, then after. Don't bring it later, but you must have it before. Okay.
Okay, teacher. Is it advisable to use a pen? Because at school we are told to use a pen while doing physics practical.
Yes, a pen is advisable. Reason, at times the marking is done at night, so people marking may not be able to see your work very well. Two, when we use pencils, at times when they pack those papers, at times that pencil work, at times it goes off. So that's why we advise you use a pen. But when you are using a pen, ensure that you are very accurate and you are very accurate such that you don't need to rub. But in case you are not yet sure, what you can do, you can first draw using a pencil. I think even now I've seen pens. I have seen children who have pens. If you can get that pen that can be erasable, that would be the best. In fact, that is the pen that I would recommend, whereby you can erase and then write again. It would be a best thing. So if you can look out for that pen that you can erase, that would be the best. It is the best because it simplifies work. Even when you have made a mistake, you can easily erase and then have another thing.
Okay, thank you.
Okay. Okay, so please, I advise everyone, look out for that pen. It will help you a lot and it will save you a lot because even when you make a mistake, it is easy for you to remove and then, yeah. Okay. Okay, lastly, Anna Joanita. Yes, ask your question. Yes. Anna Joanita.
Yes, thank you, sir.
Yes.
Okay, like during these experiments, maybe like here for you, you have the dry cells and wires to connect to the light. Okay, what if for us during our experiment, like we are given a torch, something like that without dry cells, but it's already a ready-made torch. Are you also supposed to indicate in your procedures
yeah.
that?
Yeah, now for you put what you have. Say, I think in case you have a torch and that's what the school has been able to provide, use that torch. Use that torch. For you say, a torch is, maybe I don't know how you tie, where you're going to tie it, but you say a torch is, maybe is placed where the wire goes is, or is placed beside the wire goes to provide a source of light such that the wire goes can be illuminated. That is okay. Yes.
Okay,
so
thanks.
meaning in your materials, you include a torch. Yeah, because I know there are some schools maybe that provide torches to people. So use that one. Use that one. It is very, very okay. 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 So improvise. Whatever you have is what you use. Okay. Now I'm going to talk about the errors. Because when you are making or when you are doing these experiments, one of the things you are going to find out is that you may encounter some errors, or there are some errors that may come in as you are working out or doing the experiment. So how are you supposed to handle? How are you supposed to handle them? So you need to know which errors or what things are you expecting to get. So those are the errors. Which things do you think may not make your results accurate? Those are the errors. So, but So one of the most common error that will happen on almost every experiment is what we call the parallax error. Whenever you fail to position your eye correctly, you are going to fail to get the right results. Whenever your eye fails to position itself well, you'll always get incorrect results. And therefore, I ask you, always make sure you place your eye in the right position. Whenever your eye is not in the right position, it means that you cannot be able to read the values correctly or the way you are supposed to read it. So these are the different positions. Some of you may place your eyes. All those people you are not seeing, that's what we call the parallax error. That for you place your eye at a given angle, you'll end up getting different results. In case there's a meter rule, you find someone is not standing perpendicularly to the ruler. So you'll find yourself that you are bent at a given angle. And therefore, as a result, you'll end up with a wrong answer, with a wrong value. So please and please, when you are reading these values, make sure you are perpendicular, you are in the very correct position such that you can be able to attain the results. Otherwise, you read your value, or you may see something now like this person is seeing 18.2. This person here is seeing 21.5, yet the actual value is 20. So please position yourself well perpendicularly such that you can be in position to get what you are supposed to get, the right corrective value. Otherwise, the moment you bend, you do what? You'll end up getting a wrong answer. And a parallax error is going to be very common. Most so if at all your experiment involves measuring or using any measuring instrument. And what are some of the common errors? These are some of the common errors in each of the topics. I've just highlighted the common ones, but there are others that I have not mentioned here. But these are some of the common ones. In mechanics, like I've told you, parallax will be everywhere. When it comes to mechanics, you'll find it there. When it comes to optics, when it comes to electricity, because all of them require using of the measuring instruments, using a meter rule, using maybe a voltmeter and the rest of that. So you may end up reading them incorrectly. Then for light, this one is also very common, what we call external light effects. So you find that at times, when there is too much light in the room, you may not be able to locate the sharp image. So you find that one also appearing. But some of you, even at school, you have tables that are not smooth. You have tables that are rough. You have tables that have worn out. So you find your table is like this, is bending. You find your table is like this. So you'll end up putting your ruler maybe like this. You'll put your ruler will bend like this as a result. So that one can also be another error that will yield wrong results in the end. So those are some of the common errors. Then other errors that you can meet in the different experiments when it comes to electricity, wires, like that wire, whenever you are placing that constant wire onto the meter load, you must make sure it is straight, or in case you are putting it on the table, you make sure it is straight. Otherwise, in case it has those clinks in it, those bends, then you'll end up not getting the accurate value because that one has an effect on the resistance. Okay, so these are some of the common errors you'll be meeting. Then this one of resistance, current fluctuating, this one always comes in because some of you, when you are carrying on the experiment, you read one value after you leave your thing there on for a good time, and then you remember, I didn't switch off my switch, so you go back. So you'll find that your values are going to be fluctuating. They are going to be a bit different. So that is another error that we at times forget and we make. So please make sure you work out these are some of the common errors. I've said I've not exhausted all. There are others that I've not included here, but probably they are there. I know there are others, there are very many, but we may not be able to do what? To have them. So these are some of the solutions to those errors. In case you find these are some of the solutions. So when it comes to electricity, one of the solutions, you need to make sure that you tape the ruler very well, such that that wire is taut, is very straight onto, then also making sure that the room where you're conducting your experiment is dark, or you can ask the school to put for you curtains in those rooms, such that you don't have too much light entering into the room. Most of those people who are going to, mainly when you are doing the light experiments. Okay. Then these answers will be rejected when you are coming up with a solution that repeat experiment, human error. When they ask you the solutions to the errors, yes, when you are answering in the giving solutions, the possible solutions, those ones will be rejected. Now for this experiment, what are some of the possible sources of errors as you are doing the experiment? So some of the sample answers, one of them is parallax. I've told you parallax is about positioning your eye. Failure to position your eye well, then it will yield, or it will lead to parallax. Then another one can be the working surface. So like I've said, some of the tables we have in our labs, they are not smooth, they are not flat, they are rough, and they are worn out. So that is another thing that can result into an error. Remember, when you are carrying out this experiment, the wire gauze, the lens, and the white screen, all of them must be on a very flat surface, such that they are parallel to each other. So that one can yield also. Then failure to keep the lens holder perpendicular to the measuring scale, that one can also be another challenge, can also be another error that you can make, and you end up with wrong answers. Meaning that as you are working out the experiment, as you are taking on your readings, you must take into consideration the sources of errors such that you do not make them in the end. That's why we are bringing it that before you record your experiment, do you know some of the errors you are going to encounter in the process, such that you be very careful when you are working out? Another one, okay, those are some of them. I've not mentioned them, but here when they are awarding for errors, they always say the person who has given 3, give him 3. The person who has given 1, 2, give him 1. The person who has not given any, give him 0. So you give as many as you can, as long as they are related to your experiments. Okay, I take one hand. The one who was not. Okay, Vivian Kandakwe.
Thank you so much. So my question was on the issue of the parallax and light intensity. So we already talked about them as control variables. So now in the report, when you've already talked about parallax and light intensity as a control variable, do you again mention it when you're listing the errors?
Yes,
again,
such that yes. Now that one shows that you know which areas you are going to focus on when you are carrying out the experiment. That when I'm carrying out the experiment, when I'm doing, those are the things you must control, such that you know that when I don't control them, I shouldn't expect to get correct results. Yes. So that is an error. So you need to be able to control them, because you can mention them as things you are going to control and you don't implement them. And you just stop at just talking about them. Okay. We are going to continue. Then we have what we call the precautionary measures. We have some steps that we must take in order to prevent the problems from happening, such that we can be in position to attain the correct results. So some of those are things that we must take into consideration, must be scientific in nature. Remember, we have those that are not scientific in nature. We have those ones that are so much into the humanities. Yes, so take an example, you start things of clean hands, what, those ones are so much minor. So those ones we may ignore them. So here we are looking at how are we in position to minimize the errors? Which measures are you going to take as a person as you are carrying on this experiment? Much as you might know all the errors you may encounter, but you may not have been in position to manage them. You'll find yourself, you know that light is too much in the room where you're carrying out, but the school doesn't have the curtains to put there at the moment, or you cannot even improvise and bring your blanket or your bed sheets to put at the moment. So what are you in position now to do? What are you going to do such that you minimize those errors? So, but the focus should be on the scientific measures that are related to the experiment. Yes, I've seen those ones that are not so much scientific are things like having putting on like glasses, putting on maybe a mask, putting on, those ones are precautionary measures, but those ones are not so much scientific and related to these experiments unless otherwise. So some of the precautionary measures you need to take when it comes to mechanics, those are the ones. When it comes to light, those are the ones you have to take. And when it comes to electricity, those are some of them. I have not exhausted the full list, but these are some of them. So you can add on as many as you can. Yes, you can add on as many as you can, such that you are in position. Yes, you are in great position. But these are some of the measures that we can take on. So now for this particular experiment, what are some of the precautionary measures? One, correct use of the instrument to avoid parallax errors. Even you can be specific that correct use of the meter rule such that I can avoid, or such that you can avoid the parallax errors. Conducting the experiment in a room that is dark or with minimum light, or blocking of the light. That is another thing that you can as well talk about. Another one that we can talk about can be ensuring that the surface where you're working, there are no reflective surfaces. Take an example, you may be working in a room that has very many mirrors inside. Yes, you may be working, maybe your lab is around the gym and you have those surfaces. Even the windows, some windows keep on reflecting light. So you may end up getting wrong answers. So these are some of the few that I mentioned. But when you are giving, still we give a range that someone who has given 4, give him 3 marks. Someone who has given 2, give them. Okay, now we have this part, the presentation of data. Now under the presentation of data, the first thing I'm going to look at is going to be the table of the values. Now, when it comes to the table of the values, there are some key features you must know. There are some key features the table must possess. One, always we start with the independent variable. The first value in your column is the independent variable. Never begin with the dependent variable. 2, columns must be clear and well labeled. When you are working out your columns, clearly show that I'm working my independent variables U measured in centimeters. Label them. Labeling is putting the quantity and the unit. Yes, and they must be clear. 3, that is table. Constant values shouldn't appear in the table. Take an example. You shouldn't have a table whereby, let me say, you have measured your V in centimeters, and you have, the first one was 20.0, 20.0, 20.0. Oh no, this one cannot happen. Never have constant values. The maximum, if they are even close, should be only 2, not more than 2. But the best is none. You cannot tell me that you have the same results. We can never be the same. Even if you are so related, you can just be close, but you can never be the same. So please do not have these values that are the same in the column. They are not important, or don't include them there. Okay, 3 or 4, quantity and units. Whenever you write your physical quantity, that distance, which is the object distance, write it, and also write the units that it is measured in centimeters. Yeah, so that is what it means. In case it is a UV, then write it and write its units. Then the number of decimal places. Now, the number of decimal places always depends on the measuring instrument you are using. In case you are using a meter rule, it is 1 dp. In case you are using an ammeter, it is 2 dp. However, that one will always depend on the least count of the instrument. Please do not cram. Always depends on the least count of the instrument. The reason as to why we, like when you look at the meter rule, let me say this is 0 mark, 1, 2, 3, 4. This is 5, 1, 2, 3, 4, 5. You'll find that here there is a 10. So from 0 to 10, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, like that. Then there is 20. Now, when it comes to a meter rule, you'll notice that for it, to obtain the least count of the meter rule, you'll come that you say it is starting from 0 to 10. And in between here, so I'll say least count will be 10 minus 0. Divide by how many smaller boxes are here? That there are how many? So after getting that, so you subtract two values and then divide by how many boxes are in between. Now, the number of boxes that are in between are the ones that are going to determine the least count for that particular instrument. So you base on the least count of the particular instrument in order for you to come up with which value to label. In case I have, let me make it clear. Let me make it clear such that people can know what I'm talking about when it comes to least count, because it is important for you to know the number of decimal places. Now, I use, when you look at this is, let me say this is my ruler. If this is my ruler, I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So here I have 1. Then I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I'll have 2. Now, least count means least count of any instrument is one that determines the number of decimal places to which to write. Is that smallest value that can be measured by that instrument. So that smallest value that can be measured by that instrument is what determines the number of decimal places for you to write that instrument too. Now, for when it comes to this kind of ruler, this is a meter rule. Between the starting value, which is 0 to 1, you have 10 small square boxes. So I will say 1 minus 0 divided by 10. This one will give me 1 out of 10. 1 out of 10 gives me 0.1. Meaning that this instrument, the smallest value you can read from it is 0.1. And therefore, this kind of instrument, I write to 1 decimal place. So any answer I read from the meter rule, I'll always write it to 1 decimal place. So that's what you base on to determine how many DPs I should write. When it comes to things, let me say, which one can I use? Which one is common? I use an ammeter. So when you look at an ammeter and you are reading, the ammeter is always like this. So you'll find that here, the first one may be, this is 0. I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And here you'll find you have 0.2. Then you do, the starting point is starting from 0 to 0. So I say 0.2 minus 0 divided by how many small square boxes are there? That there are 10. So you say 0.2 divided by 10, and you end up with 0.02. Meaning that for this particular one, in case it is an ammeter, you read it to 2 decimal places. Any value you obtain from it, you read it to 2 decimal places. You don't read it to more than that. The same thing happens. But always even, don't cram. I've seen children cramming. You find someone having, let me say, a voltimeter, whereby when you look at the voltimeter, maybe, okay, I've seen voltimeters that read it to 1 decimal place. So please, you continue and read 1 decimal place as that particular instrument. So do not, let me say, mainly the ones that have 1, 2, and 3. You find such, here it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here, when you get the least count, is 1 out of 10, which is 0.1. So for you, read to 1. So always let the instrument help you to determine the least count to how many decimal places you are supposed to write your instrument. It is key, and be consistent. Okay. Then the table must have at least 2 columns. For any table you draw, make sure you have those 2 columns, at least 2, the minimum. Don't draw a table which has 1 column. and you say you have got results from the experiment, that one cannot make a good conclusion. Have a table that has at least 2 columns. Then the last one, all of the readings should be recorded to the same number of decimal places. In other words, you must be consistent when you are recording your values. Let me say, this is maybe my V measured in centimeters. In case, okay, let me say V. Okay, let me say U, since we are measuring it. Don't say 20.0. Then here you say 30. 20.0, maybe 40.0, and here you say 40, maybe 0.2, something like that. Then you say, and this is 50. So when you look here, the decimal place is 1. Here it is 0. Here maybe even if I add 2. So the number of decimal places, they must be, you must have uniform values. They can add such that someone looking at your work may see the consistency existing. So you cannot write anything, you must be uniform. In case you write, it is 1 decimal place, write 20.0, 30.0, 40.0, 50.0, 60, like that. Let the number of decimal places be constant. And on this point, also let me add that your measured values, the values you are measuring from the experiment, as you are carrying out the experiment, those values you can never have when this last value is the same throughout. Take an example, you are getting V as your image distance, and the first one you write 20.0. The next one you write maybe let me say 18.0. Then the next one 15.0, 13.0, 12.0. Much as they are correct, but the last value can't be all the same throughout. Here it is easy to judge that you are not carried out the experiment, because that kind level of accuracy is not easy for you to attain, yet you have some barriers hindering for you to get the accuracy. Okay. Now here is a simple table. This is a simple table for that still the given experiment we are doing. Now, when you look at this table, one thing I wanted to bring to your attention, one is the treatment of the values in the table. I know your teachers are doing their best to make sure you know or you deal with that treatment. But one thing you need always now to remember is that whenever you are dealing with addition and subtraction of physical quantities, the number of decimal places will determine. Whenever you are dealing with multiplication and division, here we use significant figures determine. So please, when we are doing data treatment, follow the rules. Do not bring out your own rules of anything you want. No, come up, get those rules. The teachers are telling you the decimal places, the significant figures, and the rest. Now, when we are multiplying a product of 2 items, when we are multiplying 2, always we'll first consider what we call the largest product. And that largest product is always obtained through testing. You test and ask yourself, which one is giving me the largest product? So you test, the best testing is you test the first one up and you test the last one down. Take an example, I'm going to test from here. I'll have 20.0 and I'm multiplying it by 20.0. But since we have said that when we are multiplying, we consider the number of significant figures. So this one has 3 significant figures and this one has 3 significant figures, meaning that our answer when we multiply must be written to 3 significant figures. So when you multiply here, you get 400. I go down, I have 70.0 and I'm multiplying it with 11.4. It has 3 significant figures, it has 3 significant figures. Then you ask yourself, you multiply 70 times 11.4. What do you get? I'm getting 798. Now you ask yourself, on the first one and the last one, which one is the largest? Then you'll say that the last one is 798. It is the largest. So that is the first value that I'll come and I write in my table, or I can on my table. And it is the value that determines the number of decimal places which my table is going to be written to that given column. So the whole of this column that I'm having, I'll maintain to this one is 0 decimal place. So meaning everything I'm going to write here, I'll write it to 0 decimal place. Any value I write there, I make sure I write it to 0 decimal place. So I write 720. I go on, I write the next one, 625. I write the next one, 13. Yes, 528. I write the next one, like that, up to when you complete. 438, and then lastly, 400. When it comes to addition, we consider the decimal places. So you're adding two variables. I'm adding 20.0 plus 20.0. When you look at them, this one has one decimal place, has one decimal place. And since it is the same number of decimal place, meaning that the answer you get, you must write it to one decimal place. So meaning that when I get 20 here, I'm going to have 20 plus 20, which gives me 40. But since we have said we write to the number of decimal places, this has one decimal place, has one decimal place. So I write my answer as 40.0, not 40. Then I go to the next one, meaning that all the rest that will fall, I write them to one decimal place. 44.6, I write 40 plus 32.2, that is what? 53.2, 50 plus 12.5, that is 62.5. I write 60 plus 12, that is 72. So don't write 72 and for you stop there. No, 2.0. Then write 70 plus 11.4, then it is 81.4. So you draw your table in that format. So this is just the sample of the table and the answer. But one thing I want you to pay attention is the units. When I multiply U times V, I am multiplying a centimeter times a centimeter. So this one gives us centimeter squared. When I add U plus V, all of it is in centimeters. The quantities remain the same. So, and I don't write this one, avoid writing like this. When you write like this, someone may think that you have already distributed these units to the V only. So that's why I have to include another bracket to show that it is the same. Also, pay attention to how we write symbols. Yes, symbols that are symbols, you must pay attention to scientific names, people who discovered things. For those ones, when you are writing their symbols, you write them differently. So when, let me take an example. When you're writing someone who named someone who discovered something scientifically, we shall write it as a capital letter. So take an example, Newton. So when you're writing the units, you write what? Newton. So those scientists whose names are appearing as what? As units, those units are always written in capital letters. Never write them as small letter. So never write Newton as a smaller letter. Then who is? So there are very many signs, but all those signs, do not write them as small letters, always follow the capital letters. Okay, let me take on 2 questions on this part. The first one, Tom BHS. Tom BHS. Unmute. If Tom is not unmuting, I can call it Anna Joanita.
I am here. I'm here.
Yes, yes.
Okay. Thank you, sir, for that great work.
You're welcome.
Yeah. Now, my question is here. Under what circumstances can we really use a pie chart? Because I saw some of the name samples. They're like we can represent our data using a pie chart, which I've never seen in the physics practical. So that is it.
Okay. Thank you. I'm going to answer that one. Let me first take on also Anna Joanita.
Okay, sir, thank you. Like when you said about the multiplication and division, yeah, I get that part whereby you're multiplying centimeter and centimeter to get centimeter squared. Assuming we are dividing centimeter and maybe something else, how would we put the unit for that?
Okay. Okay. Now, I'm going to, okay, let me start with yours. One, when you are dividing, still you consider the laws. But when I'm dividing, let me say I'm dividing U and dividing it with V. U is in centimeters, V is in centimeters. So these ones will cancel out. So there, I will not use it. I will not use it when it comes to, But take an example, in case I'm dividing, let me say I have UV and I'm dividing it by V, something like that. What will, okay, let me say UV out of V. I'm just using this as an example. This one will be in centimeter squared. This one will be in centimeters. So these ones are 2 centimeters. Let me say centimeter squared, centimeter. So here, one of them will cancel. So it remains with only centimeter. In case maybe you have meters cubed and you are dividing it with meter, one of them still can cancel. But in case it is meter out of meter cubed, one cancels, also this one reduces and you remain with 2, meaning that now you are going to remain with 1 out of M2. So when you are writing these ones as, let me say, as units, then you can write it as M power -2.
Okay.
That's how you write it in case it is down, but in case it is up, yes. Another question? What is fine? Okay, yes. Now, when it comes to pie charts in physics, we may not use it anywhere. That practical of pie charts can appear when it can appear for mechanics. We can use them in mechanics, but it's not something very common because in physics, we may look at the trend of the graph to make a conclusion. Yes. So, and when we are to use pie charts are mainly used when you are categorizing, different things. So when you are categorizing, it can come in the mechanics mainly. But in electricity, don't expect yourself to use a pie chart. Don't expect yourself to use a pie chart in what? In light, yes. But pie charts are used on what we call categorical data whereby you are looking at the whole relationship. So that's why we can use the pie charts. Yes, but it's not something very common that you'll find in physics being used. Yes, for at this level. But it is mainly used for categorical data. And that categorical data, that question can only come in when you are handling mechanics. But maybe I will provide a sample. I'll provide a sample, but it is very common when we are dealing with, it is common, it can be common in biology. That's why they can use it. But in physics, no, we rarely have what we call categorical data in physics. So that's why at times we don't use it. It's rare for us to use. So either you can meet a line graph, you can meet a line graph can be possible. Yes, yes. But also in physics, electricity can come in where you have maybe you are making a comparison between energy consumption. In case the number of electricity is about energy consumption, take an example, they can give you 3 or 4 households and they want you to compare how they are consuming electricity, looking at, okay, yes, looking at different consumption. They can give you, let me say, a practical whereby they have given you the rates, they have given you the meter thing, they have given you the wires they have connected. Now that practical of electricity, it can be whereby you have maybe 5 people. And when you look at these 5 people, each of them is using a different electrical component. This one is having his own wires. This one, another wire, another wire, another wire. Though it is a bit expensive, that practical, whereby you have people with different standard wire gauges. Maybe this one has 28, 32, and then they ask you to compare the consumption rate. So for that one, you can use your pie chart. But that also it can come. But mainly when you are categorizing to find out who is using more, what, even the bar graph can come in from that point. Let me hope, gentlemen, I have answered your question. The gentleman who asked, kindly let me know. I don't know that it's still on. Okay. Yeah, then Monique.
All right, thank you. In the first place, like when you talked about procedures to follow on how you can tabulate in the results in the table, you actually gave us procedures to follow. Like for example, you have to start with the object distance. So my question is that necessary? Like should we write those procedures before we can tabulate the results in the table?
Yes, like here, you are making a report. So a report must show us the details, how you arrived at the result you are presenting. So you must show, those procedures are not given to you. So you must show us what you did to get those results. Otherwise, we shall assume you just got them from somewhere.
All right, all right.
Okay, okay. Okay, I think now I can continue. Those who may have questions are kindly, I'm saying, okay, let me answer one more. Kavuma Francis.
I was asking, you mind giving us variables which have different...
Giving you what?
Giving us variables, U and V, that have different significant figures at decimal places.
Oh, okay. That one is okay. Okay. Variables of U and V that have, okay. Allow me now to pause a bit sharing this screen, and I first answer that question. We are going to come back. Yes, I think I just need to take you here, and maybe I show you just one table. Where is you? Okay. Yeah, it is very possible. It is very possible. I think you'll get this work, and then you can check out. There are some sample tables whereby you can test and see, but you wanted significant figures. But allow me to use this one as just the rough figure to show you what I meant. I'm going to use this one as the rough, as something for demonstration purposes. Take an example. This is the table, and they want you to obtain, let me remove this one, not to be time, just anything. Let me call it Y. When you look at this one, and maybe they're asking you to get XY, I'm using this as an example. When you look, you still first test when it comes to multiplication. So when you look at 0.900 and you're multiplying it with 19.04, this figure here has 3 significant figures. This one has 4 significant figures, meaning that the answer you get, you must write it to the least number of significant figures. And the least number there is 3 significant figures, or what you call the smallest figures. So when I get the answer and I multiply, this is 17.136. Now, the number of significant figures I'm going to write, I'll write 3. So I will count 1, 2, 3. So I will terminate from here. But since I cannot round up on the 3, I write 17.1. But we say that when we are dealing with multiplication, we test which one gives us the largest quotient. So I'll count the largest product. So I'll come and I say 0.400. I multiply times 42.24. This one is to 3 significant figures. This one is for 4 significant figures. I multiply 0.400 times 42.24. When I multiply, I'll get my answer 16.896. So since I'm supposed to write 3 significant figures, I'll come, I count 1, 2, 3. I terminate. But since 9 is the figure that can be rounded up, then I write my answer as 16.9. Then the next thing I'm going to ask myself, on this one and this one down, which one is giving me the largest product? On 17.1 and 16.9, I will say that is 17.1. So I will come here and I write 17.1 as my first value, meaning that all other values that are going to be coming after are going to be written to the number of decimal places of the largest quotient that was dictated in the column. So all other numbers, you write them to 1 decimal place. So that's how you will determine when it comes to numbers of such. Okay. Allow me now to continue. So please, carry on and you draw this graph, these values I gave you, you can use them. Now, when it comes to plotting of the graph, is what we call now analyzing and interpreting. When you are interpreting and analyzing physics graphs, we use the graphs and the plotting. We have to determine the slope. These are the two major crucial areas you need to pay attention to. But what are the features of a good graph? What do you need to consider? One, a good graph must have a title. Let me take you back and I show you these features on one of the graphs that I have here. Okay. Hope my graph, hope this graph has come. Let me, hope this graph has come. Okay, let me share again this graph. I want to show you a good graph, how a good graph looks like. Okay, I'm going to use this graph as my sample graph to show you what I mean by a graph being very good. So when you look at this is a graph, a standard graph. So I have minimized the bit such that you may understand. One, any feature I mentioned, you will take note of it. One, a good graph must have a title. Now, when we are stating our title, you state it in the form of a graph of this against this. Now, the graph we are drawing now for that particular number can be a graph of UV against this. When I'm writing, let me zoom in. When I'm writing, I will write my quantity and I write with the units. That is a point that is key. Write your quantity and the units. In case we are writing UV, I write UV and I put centimeter squared. Then I'll come down. In case I'm writing here, I'll write U plus V, everything in centimeters. And when you're writing, try to write in the middle. Because at times when you write this side part at the end, at times when you are folding your papers, these units, at times they are not seen, and at times you fold your papers. So better you write here. Two, it must have demarcation. Demarcations are these points that show after how many centimeters are your points. So these are what we call the demarcations. These ones, it must have the demarcations. It must have a starting point. When you are drawing your start, don't draw these long lines. You draw like this, you draw like this, and then you put your 0 here and the 0 here. No, make sure that you have a small starting point such that those demarcations are very okay and clear. Three, it must cover at least half of your graph. When you look at my graph, when I zoom in, you can notice that it is covering at least half. But how do I test whether my curve is really covering the 3? Now, a standard graph for UNEV is 24 centimeters long. When you check the vertical, you'll find that it is 24 centimeters long. And when you check the horizontal, it is about 20 centimeters long. So for you, what you need to do is that when you check here and you count the number of centimeters, make sure that they are more than 12. The moment you find that they are more than 12, it means you are there. In case they are not more than 12, then it means there is something you need always to do. Then when you are coming here, make sure that it is around 8, more than 8 or 8. Here, a good one will be, I've said it will be more than 12. That one is a very good one. But in case they are less than that, it means that there is something 10 centimeters. It will mean that your curve is at least half of your graph. So when you look at mine here, I can notice that they are around 12. So it is a good graph. Here they are more than even 8. So it is a good graph because we know. So make sure you cover up that one, that at least when the triangle you have come up with, the triangle at least covers a half of your graph. Then when you are drawing your slope, make sure that all the points you have plotted are embedded within the points you have plotted. And always use your pen to draw a bold. Don't use dotted points. Always use the board, and also indicate the coordinates you are reading. So those are some of the good features when it comes to this graph. Okay, let me hope my screen is back. Okay, kindly let me ask Shamim, any question? Okay, Shamim? Okay, I think I'm fit. Yes, Shamim. Shamim, I'm not hearing you. Okay, I think let me give the chance to Karen. Karen, ask. Karen, ask.
Teacher, I didn't understand that why you put to one decimal place when you calculated on the table.
Or the other table?
Yes. Yet what you were multiplying, the values were like 3 decimal places.
Okay. Yes, Karen, you don't mute, yeah? Don't mute. The values we multiplied were to 3, right? But we say that when we are multiplying, we first consider the significant figures, that I may have this, and maybe I multiply with I'm just using something roughly. So the answer you get, we had gotten our answer 17.156. And when you looked at the digits we are multiplying, had 3 significant figures, 3 significant figures. Now, the answer, the result you get after multiplying these numbers, that answer must match with the least number of significant figures of the 2 numbers you are multiplying. So when you look at this number, it has 1, 2, 3, 4, 5. It has 5 significant figures. Yet our initial answer had 3 significant figures. Therefore, as a result, we must reduce them to match the 3 significant figures. So I will count 3 significant figures, which is 1, 2, 3. So I terminate such that I remain with the 3 significant figures. So I write 17.2. So that's why we wrote that number of significant figures. So it is because it is from the rule that we wrote 2. Okay. Yes, Alex. Alex? Alex? Okay. Okay. Yes, I'll answer the rest of the questions slowly. Now we go to, please, you are going to take notes that when we are plotting, always we shall, it's not a must anyway. It's not a must. I'm putting a disclaimer, but the dependent variables always go on the y-axis, and the independent variable will always go on the horizontal axis. Yes, so please take note. Take an example. Some of the graphs you can meet whereby you need to know where, even if they don't tell you, but you just need to know how one is going to vary with the other. Yes, so take an example. When I'm plotting, which graph can I give you? A graph about mass. Let me say I have time and mass. Yes, I have mass and I'm plotting it with time, maybe with the period t squared. When you have such a graph, even if they have not told you, for you what you need to know is that time will depend on the mass. So mass is the independent variable. Time, the period, is one of the dependent variables. So that means I have t squared here, I'll have mass here. So that's what it means. So please, you can take note of that somewhere, and then you keep reminding yourself slowly. But with the time, you'll get there. But I'm just giving an example. But I've not said it is always like that. If you are plotting t squared and maybe L, you know that time will depend on the length. So meaning that this one, the length is going to be along length is your independent variable. Time is your dependent variable. So I expect you to have length here. I expect you to have t squared. Otherwise, the moment you interchange, you'll find your graph looking a bit funny. Okay, allow me to continue. So, but is the way to remember it, always we have DI, D and then I. So that is how you can remember it. Okay. Now, I don't know how many minutes we have, but let me open the chat and people can put their question and you let me know whether we can continue because I think it is around, it is approaching midday. We have only 5 minutes. Kind of put in the chat whether we are good to continue or we can end here. Yes, you can put in the chat. The chat has been open. The next one is talking about the scale. But it is you to tell me. Okay. Okay. Okay, people are saying we continue. Now, I'm going to talk about the scale. Now, the scale, we have what we call them convenient scales. Things that make it easy for you to plot. People who have done it before have found that they are easy to use when you are plotting. Those ones, we call them the convenient scales. The convenient scales, we have 1, we have 2, and we have 5. These are the convenient scales when you are plotting. However, I want to put a disclaimer that for whatever scale you use, they can mark you. However, also take note that the person marking you will have to struggle. In case you use an ugly scale, look for the scale to mark you. Will take a lot of time, meaning he will be very critical at anything you have done. So for safety reasons, or for us to be able to ease the work, to be able to do it quickly, because people who have done before, they have found out that when you use 1, 2, and 5, they are very convenient. However, we have at worst, we can use 2.5 as part of the scale, but I'm not going to talk about it. I'm going to stay with the convenient scales, which is 1, 2, and 5. Now, all multiples and submultiples of 1 to 5 will continue. Now, when I want to expand this scale, let me say I want to get other things. When I'm going down, I'll divide by 10. So I get 1 divided by 10, I get 0.1. I'll get 0.2. I'll get 0.5. I'll get 0.01, 0.02, 0.05. When I'm going up, I'll always multiply by 10. So I'll get 10, I'll get 20, I get 50. I get 100, 200, 500, like that. So that's how we generate those values. Now, for you, always what you do, when you are calculating your scale, you want to find out which scale am I going to use? Which scale am I going to use? What do? Always look in the column of your table. Look at the tables you have. Identify what could be your largest value. And then that value is the one to help you in order for you to obtain. Take an example. I'm going to just give you a table. I have here a table whereby I have length in meters. I have 0.10, 0.200, 0.3, 0.4, 0.5, 0.6, like that. What I do, I look in the table, I look for which one is the largest. Now that one we are going to get, we call it, in case this is, let me say this is horizontal. I will call it horizontal scale indicator. It's going to indicate where my scale is. So I will say 0.600 minus 0.100 divided by, along the horizontal, you have 20 centimeters according to a standard graph of UNEB. However, 2 centimeters are always left out to cater for other things, let me say to cater for where you are going to try to put the demarcation this side also. So you leave 1 centimeter this side from the starting point and you leave 1 centimeter. So meaning 20 minus the 2 centimeters that have been removed, you remain with about 18. Yeah, in fact, even at times you can remove 2. So in case, if you want to leave more space, you can leave 2 this side and also you leave here 2. Now, these two that you are leaving are the ones that are going to help you to cater for the slope. So meaning that now you have removed 2. So you remain 20 minus 4, you remain with about 16. So when you divide 16 by 2, you end up with 8. So that's why when it comes to horizontal scale indicator, we always divide by the 80 centimeters because you are considering two boxes. So here you have 0.6 minus 0.1, you'll get 0.5. So then you say 0.5 here, divide by 8, and you end up with your answer as 0.0625. Now your task is, where does this value lie? So you come, where does 0.0625 lie? So 0.0625 is here, around this point here, because it is above 0.05. So in case it is above 0.05, that value of yours is here. So what I do, I come, I take on the next value that is larger, which is 0.1. So I will say my scale along the horizontal 2 centimeters are representing 0.1. So the way I have read my value here is the way I'm going to write it on the graph. Please do not zigzag. So I'll go on the graph. I know on the horizontal, let me say this is, let me clean this space. I'll go to my horizontal like this. This is, I'll say 0. I've got 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. Yes, and then you say maybe this was your L in centimeters or in meters. Don't add those zeros of yours. Those be constant zeros, no. Just put the scale the way it is. And it must be uniform. In case you read it there from your scale as 1 to 1 dp, write it 1 dp. In case you get, let me say here along the vertical, I can give you, let me see whether I can get 1. Along the vertical, as shown along the vertical, I have maybe, which one can I use? Okay, let me say I have about 10, 15.0, 10.0, 20.0, 25.1, 30.1, maybe 35.1, something like that. Still, I do the same thing. I get the largest, which is 35.1, minus the lowest, which is 10.0. I divide by the number, which is about 10. Because there I told you that 24 centimeters. On the 24 centimeters, remove 1 box for the title, 1 box for demarcation, 1 box that will cater for the slope, and the rest. So when you remove 4, you remain with the 20 centimeters. So since you are going to use two boxes, you divide by 2, you remain with 10. So here I will divide by 10. So you say 35.1 minus 10, divide by 10. Here your answer will get 3.1375. So what you do, you come to your scale, the convenient scale, 1, 2, 5, 10, 20, 50. So you look at where does 3.135 lie. It lies between 2 and 5. It is in the middle here. So you take the largest. So meaning I'm going to start from, I can start from 5 onwards. But in case they have not asked for intercept, feel free to start from where you are. Then I will start 0, 5, 10, 15. Now, what do I want you? Those people who have calculators, in case you have a calculator, this is how I want you to get the other values that are coming after. In case you have a calculator and you have finished to identify your value on the scale that I'm going to use 5 centimeters, what you do, those people having calculators, press shift, listen to the instructions. Okay, first clear your calc, make sure it is cleared. I'm going to press on, I'm giving instruction. I want you to place 0, place equals. I said place 0, place equal sign. Then put plus 5, plus 5. So your calc should be able to give you an answer plus 5. Then press equals. So when you press equals, you'll get 5. So what you do, continue pressing equals. So it will give you 5, 10, 15, 20, 25, 30, 35. So that's how you get them quickly. Hope everyone has picked. I've said, I repeat for those who are still getting the calculators. After identifying your scale, let me say you have identified your scale as 0.05. We are on this one. What you do, you place 0 plus 0.05. Then after that, press equals like that. You press 0, press equals, press plus, this scale you have obtained, which is 0.05. Continue pressing equals up to when you reach that value of your choice that you want. So please, so make sure you get that one. You make sure you get, okay. Okay, so I think, allow me now to summarize, I think, the truth. Okay, so that's how you do it. Those people have placed the calculator. So allow me, I'm starting to summarize such that I can be able to have some questions asked at the end. Okay, so the last part is on the conclusion. Now, what you do, you look, when you are making your conclusion, look at the graph and study that trend. Is it increasing? Is it reducing? What kind of trend is the graph giving you? Take an example. I can have a graph that is going like this. Now, in case maybe here, let me say I have, let me say this is mass, and maybe this is any variable. Let me say this is my U, and maybe this is maybe V, something like that. You can notice that when it is, okay, I'm just using this as a rough. Let me use, this is Y and this is X. You can look at this kind of graph. What happens that in case this is 5 and maybe this is 10 here, this is 20 and maybe this is maybe 30, this is 40 and maybe this is maybe 60 and maybe this is 40. You'll notice that when these values of X along the X are increasing, also these values along the Y are increasing. So here your trend is an increased trend, that as the values of U are increasing, the values of Y are also increasing. So this is what I told you when it came to, when I was talking about the resistance things, that when they ask you the relation between resistance and length, you will notice that when the length is increasing, resistance is also increasing. So that kind of trend we have, you say it is an increasing. In simple terms, whenever you meet a positive gradient, whenever you see that you are getting a positive gradient, that one, it means an increase. When you come up and you get something like this kind of trend, the graph, you will notice that here, if this value maybe was 90, and this is 80, 60, 70, and maybe this is, let me use the time, 5. Let me use years in school, 5, okay, something like that. This one means that as the years, as this one is reducing, this one is increasing. So this one is reducing, another one is decreasing. This is for negative what? Gradient. So I think you have seen such relationships. Even they exist in real life. You have seen children who come to schools whereby they join your school. The first test, this child is getting a 90. As the number of days are increasing in a school, maybe second term, the marks start reducing from 90 to 80. As this child keeps on being in school, the marks keep on reducing to 60. Before you know it, is in 40. So that kind of relation can also exist, whereby one, as the number of days are increasing, or one of the quantities is increasing, another one is reducing. So you need to study the graph and you conclude when you are making a conclusion. You say, as the value, as my quantity UV is increasing, this one is reducing, or this one is doing this and the other. Then another one is what we call the relationship between the variables. That's what I've been explaining. Then comment for any errors encountered. Maybe you can find that when you are doing, it was raining, the wind came, and everything of yours maybe went out. When maybe you are doing, the sun was too much, so light was too much in the light. So comment for any errors that you have encountered, that as I was doing, this and this happened, or this and this, resulting into this. That my string, as I had put the mass, this and this happened. So that is commenting on any errors that you have encountered. But even you can give a solution. Then comment on the hypothesis. Hypothesis is like, have you, like you said initially, our hypothesis was the mass, the man's focal length is 10. When you look at your slope from the procedure, from the experiment you have done, is the thing 10 or it is different? In case you find out it is 10, you say, my hypothesis, either it can be rejected or it can be accepted. Accepting means that your values align with what you stated. In case it does not, it disqualifies when your results do not qualify or do not match with what you outlined out earlier on. So you need to know whether your hypothesis is being accepted or it is being rejected. Being rejected means that your initial assumption is not true. You have found out that the answer you are getting is not right. And most so now when you are stating here, you may find out that your answer, you may not get the accurate answer. That's why always at times even you can give it in a range form, that my focal length may be between 9.8 and 10. So that is what happens when you are making a conclusion. So all those things can appear. Then you come, the last one is what we call the recommendation or the advice. Now for that gentleman, you find out which advice are you giving him? Do the glasses that he has given you match? In case it doesn't match, what is the way forward? Now you may find out, in case you find out that the glasses are matching, then you can conclude that the glass that the old man gave me is matching, and therefore I would recommend that let him go on and buy glasses of the lens X whose focal length is 10. In case they don't match, say, the glasses that the gentleman gave me do not match with the focal length of this, and therefore I advise him, let him go back to take measurements such that he can get the right glasses for his eye problem or eye defect. So that's how you must now be able to give a recommendation. So now those steps I've taken you through, those are the way you must have your report. You must have your aim, the variables, the hypothesis, the apparatus to be used, the procedure of the experiment and their setup, the possible sources of errors, the precautions, analysis, interpretation, conclusion. So those are the things. And then lastly, you give your advice and then your recommendation. So remember, when it comes to data analysis, you must also get the slope. Yes, you must learn how to get a slope. But I feel I have overloaded you. I've overloaded you. And I think it is really a lot. So I don't want to overload you. Maybe I look through my program and then I see whether I can be in position to give another session on this matter. But I'll first confirm whether it will be very possible. But I want to, so this is how your report should look like. Please make sure, I'm going to task those who are with the help to use the same things I've given you to make at least one report. Make one report before you go back to school. You can make one report and you take it to your teacher and he looks through. Yes, such that you know where you are going to score and which areas you need to improve. I've not talked about the scoring. Like I've told you, it is a lot. I cannot exhaust everything within one day. But please just know that your setup, drawing experimental setup, those people were asking, how are we supposed to draw? Drawing an experimental setup, 1, collect and complete well drawn and labeled, those are 2 marks. If you draw a partially labeled, they will give you 1 mark. If you draw an incorrect diagram, they will give you a 0. Getting a conclusion, they will give you the 2 scores. Writing a recommendation is a mark. So for you, everything we have been talking about, just know it is a mark. So for anything you are leaving out, you are losing out. Accuracy is a mark. Analyzing the data and interpreting it is a mark. So please, precautions is marks. So for you, don't take things lightly and say, maybe I'll do it another time. Or what? Please make sure you follow. Now, I want to give you some samples, but I'm going to give you a few. One, this is one of the scenarios. This is the exact scenario like the one we have done. However, here I have twisted, instead of giving you the focal length, I've twisted and I've said the gentleman claims to have a length of power 10 diopters. So what do you need to know? You need to know what is the power of a lens? How is it found? So here, that's why you need to go an extra. In a competence-based culture, please do the extra. Even if the teacher has not given it to you, go an extra mile to learn something on your own. Do not solely depend on the teacher. So you need to know that power of a lens is given by 1 out of F. Because I assume that this gentleman, maybe he might have remembered the power of the lens. Then you need to remember that if the power is 10, that is okay. Now, how do I know that this is 10 is equal to 1 out of F, meaning that my focal length is going to be 1 out of 10 and it's going to be 0.1. But these are meters because power is always in meters. So meaning how many centimeters that this is going to be 0.1 times 100, which is the focal length of 10 centimeters. So this is how I can twist it in another version and you think it's something different. Please, this is now requires the creativity, going that extra mile, such that you can be in position to find. Then the person asking, what is resistance? Resistance means the opposition to the flow of current. Yes, whenever there's something opposing, we call it resistance. Yes. Now, please, there are no hints. There are no hints. So here you must either know or you don't know. Yes, so you need always to have that. Okay. Let me conclude and then I'll look at those questions later. Then I think let me stop there. I will show you other scenarios, I think, at a later time about electricity. I think I have them. I have them yes. So remember, I have them here. I have some book bank that I'm developing but I will share at a later time, such that you can try out when it comes to electricity, when it comes to light, and the rest of that. But please do not forget, I've not talked about the slope, how you read the slope, and to how many decimal places you must write it. So please read. I think I'll also send this small booklet, and then you look through how you read about the slope, how you must find your slope. Slope, you don't need to write that change in y out of change in x. Just write your slope, put the values, and then write your answer. But the answer to which you are writing must be in line with the smallest list or the least count on your graph. Yes, but that one I feel, I think I'm also getting a bit tired. So let me invite questions now. Yes, I think let me answer 10 questions, and then that would be good enough. 10 only. When I answer the 10, it will be good enough. Kindly ask. I'm going to give you a chance. You raise up the hand, and then I take on those 10 people. Okay, number 1. I'm going to move in order. Shamim. Shamim, ask. Okay, Shamim I'm not getting Shamim. M, ask.
Teacher, I had a question on for the experiment of, I think, electricity. How do you count the number of like connecting wires in the circuit?
In the circuit, okay. Let me show you. Where is that one? Okay, allow me now to first disable this. Where was that? I think. Oh, okay, let me first look and I show you how you count them. Yes, and also when it comes to those electricity, please avoid shortening your wires. Yes, whenever you shorten the wire, you're causing more problems. You're causing more problems. I think that experiment was up. I think that experiment was. Okay, allow me to first stop sharing and I leave the full view. I'm sharing again. I want to leave the full view and then I show you how we count electricity. Okay, here, it is here. Now, when I'm counting the wires for this particular experiment, I'll come and I count like this. From here up to here, this is one wire, that is one. From here up to here, that is two. From here up to here, that is three. From here up to the voltmeter, that is 4. From the voltmeter up to here, those are 5. So I will say 5 connecting wires. In case here, for your jockey, you are using a wire, also include it that now those are 6. Hope I have answered you. Was it Naku? Or it was M?
Yes, teacher. And then I also didn't understand the part of where you're using significant figures when you are finding the product of U and V.
Okay, don't mute. When you are finding, how are you? Did what?
In the experiment, the one we have just done when we are getting the table of results, the one when you're getting the product of U and V, which will be in centimeters squared. Okay, like we multiplied, I think, 11.6 and 40, then the answer we got was to 3 decimal places, but we only wrote to 1.
Okay, now, don't mute. Now, when we are multiplying two variables, we always consider significant figures. That is the first rule. After you getting the significant figures, then the next rule is for you to determine how many decimal places your value is to be written to. Now, when you look back at that table, where is that table? I think the table is here. When you come back at this table, what did we do? The first thing you need to know is UV is the product. Whenever you are multiplying or dividing, the first thing you consider is significant figures. So when I look at 20.0, it has 3 significant figures. 20.0 has 3 significant figures. So when I multiply 20 times 20, I end up with an answer that is 400. So that is my answer. Then I asked myself, are these ones 3 significant figures? Because I have 3 and 3. So if they are 3 and 3, then it means that my answer, I write it to 3 significant figures. So this is 1, 2, 3. But being a multiplication, I test. I'll come down also. Always test the first one up and the last one. Those are the ones that can give you the largest product. So I multiply 70 times 11.4. Now, the answer you get is 798. This one has 3 significant figures. This one has 3 significant figures. So since all of them are 3, my answer, I'll write it to 3 significant figures. So this is 1, 2, 3. Now, the largest product or the largest answer you get after testing the two values it is the one that you consider to write the number of decimal places to the rest of the values appearing in the table. So this one has 0 decimal place. So anything I'm going to write here, I'm going to write to 0 decimal place. If I can give another example, if I had I want something of multiplying. In case I had, let me check, allow me to get something of multiplying. I wanted something of multiplying whereby one value is, okay. Let me talk about x. Let me say my x, here I have 6.0, 6.2, 6.4, 6.6. And I'm multiplying it with something like 13.4, 15.8, 16.3, and then maybe 17.4. I'll come and I say, these are the two things I'm multiplying. This one has 3 significant figures. This one has 2 significant figures. Now, this one being bigger than this, it means that always I consider the least significant figures. So meaning that when you multiply 3 significant figure and 2 significant figure, your answer, you must give it to the least number of significant figures, which is 2. So I'll multiply 13.4 times 6, which will give me 80.4. But when I look at 80.4, this is 1, 2, 3. These are 3 significant figures. But my answer, I said it must be to the least number of significant figures, which is 2. So I'll automatically remove this 4, and I remain my answer as 80 net. But I'm still testing. I go down. I say 17.4 times 6.6. So my answer I'm getting is 114.84. Now, when you look at this one has 3 significant figures. This one has 2 significant figures. So we said we write the least number of significant figures. So the least number of significant figures is 2. So I write this number to 2 significant figures. So I write 1, 1. But I will terminate this one. Now, I don't write 4. Reason being that 4 is another significant figure. So I'll drop 4. Since even I cannot round it up, I write it as 0. So now I write 1, 1, 0. Now this number has 2 significant figures because the 0 I have added is as a result of rounding off. Any 0 obtained as a result of rounding off qualifies not to be called a significant figure. I don't know whether I'm clear, M. M, are we together? Not yet.
I haven't got, not yet. On this last part of rounding off and getting 0.
Oh, that one. Now that one is a special rule. A special rule. Let me say, in case I have 11.4 and I want to write 2 significant figures, I'll count 1, 2. So I write 11. In case I have 13.56 and I want to 3, I write 1, 2, 3. So since this one I can round off, I write 13.6. But in case it is a whole number, let me say 5, 8, 6, 4, and I want to write to 1 significant figure. So I always start from the left. This is the 1 significant figure. This is the second, the third, and the fourth. What I do, in case they want 1 significant figure, I'll get this 5, I write it. Now, in case the number coming after that 5 can be rounded up, then I can round up. So 8 can be rounded up. So instead of writing 5, I'll make 6. So the rest of these numbers, I tarnish them to be 0. So they remain, we call them placeholders. So I write 6,000. So 6,000 here has 1 significant figure. So these zeros are just placeholders. In case I have, let me say 3, 4, and I want to write 1 significant figures. These are 2. What I do, I will just write 3. This number coming is the number that cannot be round, that you cannot use to round 3 on. So I write that. Are you getting it? Not yet.
I've got it, teacher.
Okay. Okay.
Thank you, teacher.
Okay. Now, Shamim, are you back? Okay. I'm failing to get Shamim. I go to Oppo. 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 Okay, Oppo. Yes, Opo.
Okay, may I have like 3 questions, eh?
Yes.
My first question is like, sometimes after plotting the graph, we're supposed to find a slope, maybe to get our answer, focal length, and at some point you see they're telling you find the intercept. Now, the intercept also sometimes can lead us to, let me say, the focal length or maybe the slope. Now, when do you get the slope to get your answer, or when you get the intercept to get your answer? And how do you know you're supposed to get the slope or intercept?
Okay. Now don't go off. Now, one, to get the intercept, it depends on how you derived your formula that you are going to plot. That's where the intercept comes from. Like I think I showed you, let me go back. I showed you when I was deriving the mirror formulas, when I was deriving the mirror formula for focal length, I showed you 2 approaches. I showed you that there is an approach that can lead you to getting an intercept, and there is an approach whereby you may not get the intercept. So that one depends on the formula that you are going to plot. That's where it comes from. The way you express that equation you are plotting in form of y is equal to mx plus c. Some have the c. Others, when you make the subject, you don't get this c. So the ones where you don't get the c, those are the ones where you don't have the intercept. The ones where you get the c, those are the ones where you get the intercept. I don't know that it is okay.
Yeah, I've understood. Meaning, if the intercept is there, if the C is there, I get the intercept to get the focal length there.
Yeah.
Okay, my other question is like, does that part which says enter your findings in a suitable table? Let me say including values. Here, like we have of U, V, and V, maybe squared V plus U. Okay, like let me say in experiments of like mechanics and electricity, how will you know you're supposed to enter your results, including results of maybe this multiply by that and add by that? How will you know?
Now, how to know it? Still, everything is going to come from the formula. The formula you come up with, that formula that you are going to derive is what determines what you have to put. Take an example, is that when we are deriving this one, you notice that you had UV in the formula, you had U plus V. I think I showed you for mechanics, when we are deriving for mechanics. For mechanics, we had, it was the principle of moments that I used. So when you look at that principle of moments, you notice that you had, I think, I don't, okay, let me recall. I think it was MB times something. Okay, let me go there. Don't go. It was, hey, I don't know. Oh, where is it? Okay, let me first go. Now, it depends on the formula you have come up with. It is that formula that determines what to include and what not to include. So now, a case in point like this one, whereby you have a known mass, maybe you call M, and also you have a known mass of the bottle. So when you use the thing, you'll have something like this, MBD2. So since D1 and D2 are varying, so you can decide to say D1 is going to be MB out of M times D2. Meaning that in your tables, these values you are plotting are the ones that you are going to include. I am plotting D1, I'm plotting D2. So those are the values you include in your table. Those values that are changing. But everything comes from your table. In case your table, let me say you are dealing with things of oscillation. Now you need to know this formula, L out of G, this one, whereby you divide by 2 pi, divide by 2 pi. So you end up with T out of 2 pi is equal to square root of L out of G. So when you square both sides, I square both sides. So I'll end up with the period T squared out of 4 pi squared is equal to L out of G. So now here, since you want, I think, in case you want acceleration due to gravity, it means that you are going to vary your length and the T squared. So meaning that in your table, you need to know, I have L, yes, I'm measuring L. What about T squared? How is T squared obtained? That to obtain period, I will need the time for oscillation. After the time for oscillation, I will need capital T, which is period. After period, I will need T squared. So that's how you can identify them. But everything comes from the formula that you are going to use for your plotting. I don't know that is clear.
So you first come again. You first come again.
Which one?
You first come again in this one of like determining how you will know that you're supposed to include values of this and that. You first come again.
Okay. Now, when you look at this one for acceleration due to gravity, you are noticing that I have t squared out of 4 pi squared is equal to L out of G. Now, in form of when I cross multiply, I'll have t squared out of 4 pi squared, G is equal to L. Like I've advised you that always write it in this format. And always better, you make your independent variable the subject, which is L. So this one will equal to let me write G, t squared out of 4 pi squared, then plus a 0, because we don't have a C. That means that your M here, for this case, your gradient, is something that G is a constant out of 4 pi squared. That is your gradient. Now, t squared is the only thing this side that is changing, and L is going to change. So meaning you're going to plot L against t squared. Now, if you're going to plot L against t squared, you're going to ask yourself, L, yes, I have it. What about t squared? Do I have it? T is period. But how do I get period? Period is the number of oscillations made per second. So meaning I will need time, so I first find t. But I know period t is given by t out of the number of oscillations. So in case you have made it 20, I'll say out of 20. So I'll find also capital T. After finding capital T, but I am plotting t squared, so I'll include also t squared. I don't know that I have picked it.
I have picked something. Then, yeah, pick something. I think that's all. Thank you.
Yes, but everything, you must know those formulas. That's where it is going to come from. In order for you to know what other things, always, but not like, but I've said, always make sure you have two variables. There are some things where you are not going to stress yourself as long as you know what you are doing. Take an example, in case it is electricity, and they want you to find resistance. You know that I'll divide by I divide by I, meaning that resistance is given by V out of I. In case I don't want even to reach this side, I'll just go, I say V is equal to IR. Now I know I can form Y is equal to MX plus C. So I can say V is going to be my Y. I is going to be X because it is the voltmeter reading and the current reading that I'm interchanging, meaning that R is the resistance, which is representing the gradient. But when I look at this equation, I don't have C. So meaning C is 0. So meaning I am going to plot a graph whereby Y is going to be V, and here I'll have I. What I get is going to be resistance, and resistance is the slope of this curve I'm coming up with. So meaning in my table, I'll have V, I'll have I. Then, but here, now you need to know that in order for you to get V and I, you need the length such that you keep on varying the length, such that the resistance keeps on changing because it varies with the length.
Thank you, sir.
Okay. Yes, Jerome, Saint Mugaga.
Yes, sir.
Yes.
Thank you for the service.
You're welcome.
I had a question.
Yes.
Our physics teacher forgot to clarify us on where to plot lines of best fit and curves. So please, may you clarify? And I'm requesting that you change the mark because we can't see the blue. Yes, thank you.
Like when I'm writing on this screen or on the graph?
When you're writing on the screen.
Okay.
But
Now,
it was okay.
Okay, don't mute. Now, when we talk about a line of best fit, it has three definitions. One is that line that can go through all the points you have plotted, or it is that line that can leave equal number of points on both sides. So those are some of the two definitions. So when you are plotting a line of best fit, one, make sure at least it goes through many of the points you have plotted. So in case I'm plotting, it will come like this. So for you, look out for which line is going through many of the points. You can plot your points whereby you have something like this. And when you look at it, you are noticing that either I'm getting a line like here, or I'm getting a line like here. Now, for such a case, it can be that line that doesn't go through any of the points, but when it is leaving an equal number of points on both sides. So it can be the line like that. That one can also be a line of best what? Best fit. It can be that line whereby it leaves equal number of spaces. You can have something like this, and you have something like this, maybe when you have plotted. I'm just assuming. So here, your line of best fit can pass here. It leaves an equal number on both sides. But when you are drawing in physics, look out for that line. When you look at it, at least it takes many of the points. And it leaves on the upper side, it leaves an equal number. Also down, it leaves an equal number. So that's what we call the line of best fit. I don't know whether that was the question.
Yes, sir. But where do we plot curves?
Curves. Now, curves always comes when we have varying, when we have a formula that yields to parabolic curves. But that one is mainly when we are dealing with temperatures. When you meet experiments that involve cooling, that one is possible in mechanics, which involves cooling. When you want to see how things cool, for those ones, mainly the temperature, you'll find that you'll get a curve. It can be a curve of that nature. It can as well be a curve like that. Yes, but at this level, it will be rare for you to meet a curve. But also, you look at the pattern of the points you have got. Don't force things. You may come up when you are getting things like this. So for that one, you use your free hand and you do the curve. Then to get the intercept, look out for the sharp points and draw a tangent across it, and then you come up. But the trend of the points you have got are the ones that determine whether it is a curve or it's not. But that one, it is rare. For a curve, it is rare. Yes, I don't want to tell you the truth that you do not expect it, but yes, but it is possible, but mainly when it is cooling. When you find experiments that involve cooling, yes, that's where you can find it. Hope we are together.
Thank you, sir.
Okay. Then Chidabo. 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 Okay, I'm failing to get Chidabo. Joel Mukwaya. I promised only 10 people. We are almost. Mukwaya.
Okay, thank you. Good afternoon.
Good afternoon.
So thank you for the session. But then now that it has been an online session, the problem could have been a network. That's why people were coming on and then leaving. Now that you've been recording the session, could you please share the recordings?
Yes, the recording is going to be shared.
Okay, thank you.
Before the end. Okay.
Teacher.
Yes.
Shami, I'm asking the formulas, like how do you know the formulas? And for example, the electricity thing, how do you know?
Now, when it comes, okay. Now the formulas one, when you go to your book, the common formulas we have in electricity, the common one you have is the one of the Ohm's law. That one comes when you study Ohm's law in senior 4. That's where you can find that one. So that is one. So V is equal to I, R. So this one you find it in Ohm's law and electricity, and it's going to be a common one. Another one, your teachers can give you a hint. Another one, it's for internal resistance. Also, you can find it there. Another one that is common in mechanics is about moments. That one is also common. You have, I think, you have dealt with the moments in mechanics. That one you have dealt with it. Then another one is in light, which is 1 out of F is equal to 1 out of U plus 1 out of V. That is another common formula that you need to know. At least that one is okay. Another one you need to know is the one of density, the one of mass out of the volume of substance. That one is also possible. Then that one, you are going to add on the one of relative density. whereby you need to know that relative density can be the density of a substance out of density of water. So here they can give you a substance, maybe paraffin, water, milk, what, and they want you to make some composition or to find out the purity, or they can give you still on the relative density, whereby you need to use the mass of a substance divided by the mass of an equal volume of water. That one can also be possible. They can also, they can give it to you in form of weight, because the relative density can also be given in form of weight, whereby you need to know the weight of a substance out of the weight of an equal volume of water. That one is about density. So those are some of the common ones when it comes to relative density. That is mechanics. Then another one, you are going to go under Hooke's law. You have also studied under Hooke's law that force is equal to Ke, where E is the extension. You have also done that one. That formula is also very possible. There are very many practicals that can be set within that field. That one you need also to know it. Another one can be which area? So you want me to complete for you everything. Another one, still under mechanics. This one is always given to you when you are dealing with acceleration due to gravity. I know teachers can reach somewhere and they state that formula somewhere. That one also you can find it under that side. Then another formula that is a bit common that you need to know can come where? In moments. Yes, also in moments, whereby you say clockwise moment is equal to anti-clockwise moment. That one you need also to be familiar with it. You want more formulas? Yes. Yeah, those are some of the common ones that I can give you for now. But your teachers, like I think I told you, those who were on the call, I advised them to go on and discover more formulas. In light, in case maybe it is about refractive index, you need to know that one, sin I out of sin R. Yes, avoid those allegations that glass blocks cannot be brought. I told you one of the applications that when they're manufacturing glass, glasses of different materials are used differently. That's why you have seen cars that don't allow bullets to go through. You have seen cars that where a bullet can go through. So those ones are properties of glasses. And in order for you to study those properties, you need to know the refractive index of the different materials. I think that can be enough for you today about that. But you can discover there are very many other formulas that I have not been able to give you. But those are the common ones. Those are the common ones I can give you. Yes. Hope we are together. Yes. Gary Oskol.
Good afternoon.
Yes, good afternoon.
So I did not understand where I use the calculator to get the scale on the group.
Oh, okay. Do you have your calc there? Do you have a calc?
Yes.
Place 0. Place equals. Finished?
Yes.
Plus.
Yes.
Are you getting answer plus on your calc?
Yes.
Now you put in the scale you have got. In case you have got 0.5, put in 0.5 and then place equal sign. What do you get? Got it. So you place in equal sign, and then for you just continue pressing equals. So it will bring for you those different values that you are supposed to put on your graph.
Okay.
Okay. Lauren, Lindsay, unmute at the same time. Naboth, unmute. Yes.
Yes,
but
teacher.
Yes.
I was trying to inquire if it's a must that we should mark the coordinates on the graph while plotting.
Or like to mark them like demarcation? Oh.
No, like after, like when you want to get the slope. Yeah,
Or
there were some coordinates.
Oh, to mark the coordinates. Okay, it may not be a must as long as you read them and you put them down here very well.
And
Okay,
then
let's
you were like, when finding the slope, we shouldn't use those things of changing y out of changing x. What if I use them?
No, they are not going to penalize you. They are not going to penalize you, but you are wasting a lot of your time. Yet you have only 2 hours. So for you, the moment you have those two values, let me say 25.1, and maybe for you just press it, as long as you know that I will say 25.1 minus maybe 13.4 out of this. For you just press in the and put the answer.
Okay, fine, thank you.
Okay, yeah. But by the time you take writing changing y out of changing x, this, you have already wasted some time of yours.
Okay.
Okay, Nabot? Nabot? Okay, I think I'm failing to get Nabot. Icon and hope. Icon, hope. Unmute. Any of you is able to unmute. Mirembe Diana. Winnie. Anyone who has?
Yes.
Yes.
Teacher.
Yes.
I was asking if your setup was already given in the question. Can you draw it again? Is it a must or not?
Yes, like I've said, Diana, that those setups you can alter them. But still, since you are making let me say, you are making a report you are going to submit. If you are making a report, meaning that you must give the details of how you have been able to carry out, how you have carried it out, the steps you followed, and the rest of that. So in case you jump it out, you may miss some marks, like 2. Yeah, because I told you that on the scoring guide, they can put the experimental setup. And always, it is very hard, Diana. The truth is, it is very hard for you to describe someone you are not seeing. I cannot describe Diana because I've never seen you. But when I'm seeing you, it is easy for me to describe that Diana is tall, Diana is this, Diana is this. So the use of you having it there is to help you to describe and talk about what you have drawn. But in case it is wasting a lot of your time, you can ignore and you risk losing the 2 marks. Yeah, but it is
Okay,
advised.
teacher, now if yes, thank you, teacher. I also have another question. But if the materials in the question, like if the setup is given as a hint in the question, and the materials you're provided with, you're missing some, can you skip out those?
Now, there are some materials that you can ignore, but there are some materials that cannot be ignored. A case in point now, like for light, in case you don't have a ruler, you cannot. So for materials, you always ask your teacher for assistance. You tell teacher, I want this, and they will provide, unless when the school doesn't have them. Yeah, but for any material you need, you must always ask your teachers to give them to you. Okay. Help, Icon, Swift, and Jenny.
Teacher.
Yes.
I was asking that, is it fine if you get a negative graph?
Yes, it is very okay. It is very okay. The negative one.
So does it depend on the scale, or
No,
how do you get
it depends on the equation you have used there.
Okay.
It depends on the equation you came up with and what you have plotted.
Okay.
Yes, it depends on what you have plotted. Take an example now, like for V is equal to IR. For those ones, it depends on how you have interpreted it. Yes, that's when you can come up with those negative things. But it is possible for you to come up with that, with a graph with a negative thing. But whenever you come up with, always you need to learn how to interpret. That one mainly happens when one quantity is increasing, another one is reducing. So when you have such cases, it's very possible. And don't say it is hard. Take an example. At times when you are plotting that graph of V against I, it is V against I, depending. You may also come up with such a graph. So it is possible. Don't worry.
Okay, thank you.
Okay.
Yes, teacher, can I ask a question?
Yes.
At some point, you are like, we shouldn't mention the type of lens while writing the hypothesis. What if it's given in the scenario or task? Can't we still write it?
Yes, but now that one is hard. Okay, it is possible. They can give it to you there, write it. There you can write it. Yes. That there
Okay,
you can write it. But in case they have not, don't commit yourself. Because even you may be there when you are not sure of. Then there's someone who was asking about curves. Yes, when you are handling Hooke's law, in case the question is about Hooke's law, whereby we have, yes, when it is about Hooke's law, you can be able to get that. Yes, even when you are determining the period and of the pendulum bob and length, it is very possible for you even to get that curve. So when you look at the trend, you have to check out. Help me, Monique, Rocket, Vian, please unmute. Yes? Okay. Vivian?
Teacher, my was on the thing of curves and lines.
You what?
I didn't understand like when we draw curves and when we draw lines. I thought in physics it's like line of best fit all through.
No, it can be a curve depending on the experiment you are carrying out. Have you done Hooke's law? Have you done Hooke's law? Yes. So it can be a curve depending on the experiment. But like I've said, curves are going to be rare. For you to get a curve, it will be a bit rare, though it is still possible. But it depends on the kind of, like I explained, like when you are carrying things of cooling, that one is very possible for you to get. When a question is about gas laws, that one is also very possible. Yes, so that's why you can meet curves. So, but curves are also possible, but that one is rare. That one is rare. It is rare. In fact, it has not appeared for quite a long time. But that one is mainly for advanced bits. So that one, just have in mind that in case the points you have got are coming up with a curve, then you go on and draw that curve. Okay.
Excuse me, teacher.
Yes.
Yes, teacher, I wanted to ask if what topic we're actually handling today, because some of us, okay, I joined late. I found you guys ahead, and if there were maybe a recording or something.
Yeah,
and
we
also
are
as in, is this lesson for Form 4s or for Form 3s?
both of you. It is for Form 3s and Form 4s. Yes, it is to help them handle now the practicals.
All right. Sir?
Yes.
I had a question.
Yeah.
Like you talked about at the part of the scales, there is where you reach at a point and you're like you wrote 1, 2, then 5, yeah? So after getting the scale, maybe the horizontal scale when you divide it by 10, right?
Horizontal 8.
So yeah, I mean by 8, So you reached a point where you got 1, 2, 5. There is how my network goes there. So I really never got that thing. Yeah.
No, like we said, that when you are formulating your scale, it is 1 to 5.
Yeah.
And then any multiple of them, like when you want a smaller scale, you keep on dividing by 10, 0.1, 0.2, 0.5. You keep on dividing by 10, like that, like that. Then in case you want something bigger, multiply by 10, multiply by 10, multiply by 10, multiply by 10, multiply by 10. Are you getting it? Yeah?
Yeah, so after that, what happened?
No, like after subtracting, you come here and you look for where your scale is. Let me say you have subtracted and you have got maybe 0.3. You come here and say where does 0.3 lie? that it is going to be between 0.1 and 0.5. So now it lies between these two. So now you take this biggest among the two. So it's what you are going to use on your graph, 0, 0.5, 1.0, like that.
All right. So that means the scale begins from 0 too, right?
Okay, it depends. In case it depends on the values you have. You may find that your smallest value in the table is about 1. Maybe it's about 3. And the scale you have got is 0.5. So you need to keep on. That's what I was telling you. Place your calculator. You say 0. You say 0 equals plus the scale maybe you are going to use, which is 0.5 equals. So you keep placing up to when you reach a point of your smallest value, close to your smallest value. In case your value is starting from 3.0, then there is no need for you to have very many redundant values. So you start from 2.5, 3.0, 3.5, 4.0, like that.
All right. Well, it does not necessarily mean just because it's a graph, I have to start from 0. I may start from a value that's inconvenient for me, right?
Yes, you can. Yes, any value that is inconvenient, as long as it is within the scale range, and as long as they have not asked for the intercept. And as well, because whenever you have an intercept and they want you to find an intercept, you must start from 0.
All right. Thank you so much.
Okay. Then Ranzi. Okay, parts, Prudy parts.
Sam,
Yes.
like when you're having those practicals on electricity, like when you're using the ammeter, there is some way that you can connect and the ammeter doesn't feed. Like, how do you solve those things? You don't get those inconveniences.
Now, some of the key things, in case you find that your ammeter is not reading, one, you may have a faulty wire. The wire, those wires you have, they may be these old wires that are faulty. 2, you check on the dry cells. 3, check on the way you have connected the terminals. 4, the ammeter may need calibration. You may need to check because some ammeters may be spoiled and for you think it is really working. Yes. So that is one of them. But some of those ammeters that have stayed for so long at times are faulty. Yes, and they may need to be checked. More so whenever you find that your ammeter you are using is not at 0 mark. Yes. And always, even you can, before you start doing or connecting, always connect them and see whether that pointer can move. Always connect 2 terminals across it with a cell and check whether it can move.
Okay. And also how to find the slope.
The slope?
Yeah.
Now, to find the slope, do you know how to draw the graph?
Yes.
Now, after drawing your graph, let me say this is the graph. And this is the line I've got. I have a point here, I have a point here, a point here, and a point. So the slope must be that right-angled triangle that is going to enclose all the points you have plotted. So for you, what you do, make sure you just trace out a good right-angled triangle. And that triangle must be able to cover all the points you have been able to plot. Now, after doing so, read off the coordinate here. Let me say it is 10 and 100. Come read off the coordinate here. Maybe it is 3 and maybe 10. Now, you'll have 2 points, 3 and 10 and 10 and 100. So this is 1x1, maybe y1, x2, y2. But these ones, you don't need to do them. Then you say slope is the change in y out of change in x. But I've said don't write these ones. For you start, say 100 minus 10 divide by 10 minus 3. And then you get your answer.
Okay. Thank you, sir.
Yes, but when you are dealing with electricity, do not forget your voltmeter must be always in parallel. Yes. So the positive terminal must be connected to the positive source of the EMF. Then the negative to the negative source. Otherwise, you may start finding diffraction and other diffraction in the anti-clockwise direction or backwards. So the moment you find such, it means that you have connected one of the wires in the wrong place. So it's just a matter of you changing. But the most important thing, before you start on the electricity practical, make sure you check that your ammeter and the voltmeter pointers are at a 0 mark. That is when you know that I'm going to obtain correct readings from. But in case it's not there, then it means that your pointer may not be steady and you'll end up getting wrong results throughout. Okay, I think, okay, I think, Lukwago, you are the last. Lukwago, you are the last. Shamim, I failed to get you, much as your hand has been up for so long. Okay. I think...
Yes, teacher, isn't 2.5 a convenient scale?
Yes, I said 2.5, it is at worst. When you have tried 1 to 5 and they have failed, at worst. Yeah? That one is like that dangerous person you bring in. Eh? Like you may have all the good people, but they might be that dangerous one you may bring in at last when everything has failed. So 2.5 is not a convenient, but it is, you bring it at worst when everything has failed.
Okay,
so the
fine.
convenient ones are 1, 2, and 5. So 2.5, you just bring in at worst when things are not working out. Okay. Okay. Philip Long, conclude, or Lukwago, one of you. But if you are failing, okay, I think I'm failing to, okay. Now allow me to stop now the sharing. Now I know some of you, Lukwago, ask before I go off.
Sir.
Yes.
What if the coordinates on the graph are not on the same line?
On the graph are not in the same line, eh?
Yes.
Now that one is also possible. Looking at other factors, like we have said that in practical, at times we encounter errors. So those are some of the errors we can encounter in the process of doing. So in case you are seeing them, they are not, and in most cases, you may not get all of them on the line, but at least make sure you have 3 of them are on the line. As long as you have at least 3 of them, in case you have plotted 6, at least have a half of them lie along the line. And then the rest, let them balance along the line. Hope that is okay. At least there must be 2 values that at least are along the line. So allow me to just... Okay, how do we know the... Okay, I'm just perusing through the chat. How do we know the formula we have to use? Because formulas are main. How do we know that? Yes, now for light, Chirabo, you need to know that for light, that formula I have given you, 1 out of F is equal to 1 out of U plus 1 out of V is the most common one. Once it comes to meters and lenses, and when it comes to glass blocks, the ones of refractive index, that one is very common. Where is the recording going to be sent? That recording is going to be on the YouTube channel of Holistic, but we shall share it in the WhatsApp groups. Okay. Here, Alex, this is me, teacher. The bid to get the form we have used to depend on fund. Good have mass and mice. Okay. Okay. Yes. Okay. Monique, I think it may, because Monique Rocket was saying, sir, I would like to, which school do you teach from? I want to come to your school. I don't know whether, yes, the recording is going to be shared. I'm going to share that recording, I think by 3 p.m. It will be there on the YouTube channel. I'll share in some of the WhatsApp groups I'm on. Okay. Yes. Now, during the procedures, now, you are not given the procedures. You must just come up with those procedures. Yes. Yes, you come up with those procedures. They are not given to you in the paper. Yes, I will share with you more revision questions. I will share with you more revision questions. Yes. Okay, okay. Okay. Yes, those scenarios I'm going to share. I'm going to share as many scenarios as I can. Yes. So those asking for biology, chemistry, those seminars will happen in June. We are going to have math seminar in June. We shall have chemistry, I think that following week. Yes, around June, July, we are going to have very many, but all of them are online. All of them are going to be online seminar. Okay. Yes, okay. I think this is enough. I've gone through some of the questions I could in the chat. Those ones I've seen. Yeah. But what I wanted to just give you is a hint such that you can prepare yourself very well for mocks. But then when you come back, then we shall be able to polish up. When you come back for second term, I think we shall have, yes, those who are leaving school, this is the last. Yes, those who are saying online, we shall invite schools to come online. We shall invite school to come online. Yes. Now, those people asking, how do you draw the right angle if the last question is not on the line? Please make sure when you are drawing the line of best fit, let it be able to go beyond that last digit of yours you have plotted. Yes, let it be able to go past that last digit you have. Yes. And you are having a eye defect. Yes, make sure you collect the eye defect info. Yes, we are going to invite all schools. We shall invite the schools and even Namagunga. Yes, I think Vivian, I think my teachers at Namagunga, some of the teachers taught me at Namagunga, probably I'll invite teacher Stephen. There is a teacher called Stephen Mugwika, something like that. Yeah, but we shall invite you just because we invite schools online, but many of schools may not wish to come online. But we shall, Vivian, maybe you'll inbox me and I will see how we can invite. Otherwise, thank you so much everyone for attending. Let me wish you a good day. Probably let me ask you, can turn on your cameras. Let me allow you to turn on your cameras. You can turn on your cameras, even you can unmute, no problem. Yes, we shall end here. Yeah.
So how are we getting the questions?
The questions I'm going to share them on the WhatsApp group. I'm going to share them on the WhatsApp group, and then I'll allow you to, I'm going to share them on the WhatsApp group where I am, and then you'll be able to pick them. You can be able to pick them from there. Okay. Otherwise, I think we are going to end here. Let me wish you a good...
Some of us are not in the WhatsApp group.
The WhatsApp group, let me swing. Okay, let me get that group here, and maybe I share it. Those who can join. But that's where I usually share them. But I'm also going to share to other groups where maybe your teachers are, such that they can be able to pick them for you. But also I want to thank all the teachers that have joined this session. Yes, I've shared the WhatsApp group. You can use that one to pick the question. Otherwise, let me wish you, I think this is Mr. Musoke.
So the name of the YouTube channel, please.
Yes?
The YouTube channel. The name of the YouTube channel.
It's called Holistic E-Learning Platform.
Pardon?
Holistic E-Learning Platform.
Okay.
Okay. Okay, let me wish you a good evening. Shamim? Okay, bye everyone. See you next time. Yeah.